Hey guys, quick shout out. I want to say thank you guys so much. We hit 25,000 subs. That is way beyond what I ever thought we would do. I was never trying to make this that big. I just love doing this. And so I thank you guys so much. I've seen it help a ton of people, and you guys have told me how many people have helped. That's been a huge inspiration of why I keep doing this. Thank you guys so much. I wanted to do something special for my 25,000 subs. So my #1 video is actually the Linux fundamentals. You've seen I've been slowly releasing it. This video is the entirety of the new Linux fundamentals module completely as in order so that you can walk through it. It's a very long video, but I wanted to get you guys appreciation and say thank you guys for all the support you guys have done. If you guys are also curious, check out the Patreon. We have a bunch more content in there. That's growing quite a bit. We just released our 2025 book list on there. So thank you guys so much. And if you guys want to chat with me, hop in the Discord, whatever. Thank you guys. Let me know if there's anything else I can do. You can put video requests and everything else in the Discord. But this is my thank you to you guys. Thank you. I can't say it enough. And it really, really means the world to me. So thank you guys. Hope you guys have a great day. Yo, what's going on, guys? Welcome back. Today I'm doing a video that I'm pretty excited about, actually. So long story short, that real long pause was because I changed my headphones and I can hear myself talk and it threw me off. But before we get started, guys, this is one of my most viewed videos in my entire channel. So if you're watching this, thank you. Hit that like, hit that sub button, please, guys. It helps out tremendously. And now we're going to dive into it. So this is Hack the Box Academy Linux Fundamentals. Now, if you've watched my video before, I've done this box. But if you notice, it says I have all these modules that aren't done. They've added a bunch of stuff to this. So I want to kind of give you guys an updated version. I've had a lot of people ask me, like, where's the next one? Where's the next one? And it's because there was no other ones until, you know, I posted that video 2 years ago. So we'll go ahead and hop into it. I'm going to break this up into 2 videos, or try to, depending on how long it takes. I'm going to go from introduction, the shell, workflow, and we're going to stop there. And then we'll do system management, Linux, and Linux hardening. So if you guys are watching this and you're like, hey, where's the rest of it? It will be coming hopefully either the following week or later this week. So let's go ahead and dive in. So the Linux structure. So I'm not going to read you the history. You can read history if you want to. But one thing that a lot of people don't realize is, like, Linux runs the world in a sense. Windows is the main proponent for users, end users, right? When you think of like enterprise systems, when you think of like working in large companies, when you think of all that stuff, you think of Windows. But what you're not seeing is on the back end, a lot of stuff's running on Linux. You got your server, your Apache servers for like websites. You've got your all your different things with like your Android devices, your IoT devices, or IoT devices, your critical infrastructure. Like, there's so many things running on Linux that people don't see. So that's why it's super important to understand. Mac OS is Linux, Red Hat, any of that stuff you've heard of, and we're going to talk about distros. But the big thing here, and this is a philosophy they say, but this is a good way to think about it in general. Everything is a file. That's something once it like clicks in your head, Linux becomes infinitely easier. And it's every single thing is a file. Everything. Meaning, if you want, you know, if you want to see how does cat, which is a command we'll talk about, run, that's a file. You can go to it. You can look at it. You can see what it actually is running when you say that. It's a binary, right? So anything that's running, you can view. Any application, anything, you can view the code, you can view it, right? And so that's something that Windows technically does allow. It's much harder to navigate Windows and find those things, and there's hidden files, in Linux that we'll talk about. But Linux, when you think about it, everything as a file, it makes sense. You'll start to see as we progress through it. Think of everything in Linux as a file explorer, like, you know, your regular directory on Windows if you're used to Windows, right? So small single purpose programs. This is what makes Linux so useful in large settings. Is these are single purpose programs. It doesn't have all that bloat that Windows has a lot of times, right? This program offers many different tools that we'll work with, blah, blah, blah. Usually, if you're designing something in Linux, it's for efficiency. It's not to look pretty. It's not to, yes, there are tools out there that have like a nice GUI interface. And it's so nice and da, da. But most people that put any effort into Windows operating systems as far as system development and stuff, they're trying to get efficiency out of it. That's why they're using Linux, because it's lightweight, it's simple to set up, it's easy to harden if you know what you're doing, and it's very, very useful, right? So ability to chain programs together to perform complex tasks. So again, it allows us to take those simple tasks. That's what all Linux is, and that's what all computing is. But on Linux, it's just simpler. It's just easier to see. And it is taking all these minute tasks, chaining them together, and creating a very efficient thing, right? And Windows does this too, but Windows has a lot of bloatware. It has a lot of stuff that runs that doesn't really serve a purpose, but it's like nice. Like an example is the print spooler service, right? That's an example on every Windows computer it runs. Are you printing all the time? Not necessarily. So does it need to be running all the time, right? Not necessarily. And Linux has there's all these different distros with different versions of things like that. But just know Windows has a lot of stuff that's running that's not needed. And Linux takes that and then basically compacts it and makes it much more efficient. Avoids captive user interfaces. So again, we talked about this. It's mainly designed to work in the shell. It's designed to work on the command line. Super simple, super easy, and quick, efficient, that type of manner. Configuration data stored in a text file. So if you have any sort of configuration file, right, any way that you need to program something, change something, configure any of that, it's stored in a text file. You edit the text file, it's now reconfigured, right? In Windows, it's not that easy. It's sometimes very complex to change that, and Linux makes that super simple, right? This is an example, right? Etsy password, we'll talk about that file, but it just stores all the users. Hey, awesome. I know how to find all the users now. In Windows, do you know how to find all the users? You can go, open up users and computers and all that stuff. But in Linux, you just go to that file. Real easy. Everything's a file. Remember that. We're going to keep saying that. All right, components. You got your bootloader. And if you guys have ever worked on any computers or anything like that, the components are pretty much the same on Windows, but you got a bootloader, right? You got a piece of code that runs telling it what boot process to run, right? Do you run, what hard drive do you look at? Where's the boot configurations, all that stuff, right? You got your OS kernel, and this is going to depend on what OS you're using. We'll talk about the distros, but you're going to say, hey, this is the kernel, right? The operating system. It's going to actually manage those resources that your computer's using. Then you have your daemons, right? Background services. This is what I was talking about, like the print spooler service in Windows, right? It's a background service. It's running, but you're not seeing it up front. You're not watching it run right now, right? So you have your daemons. Their purpose is to ensure that key functionalities such as scheduling, printing, and multimedia are working correctly, right? And that's an example where I was saying like the print spooler service runs on Windows. Does it need to run all the time? Not necessarily. It only needs to run when you're going to print, right? And so this is where it would run in the Linux portion, in daemons, right? Then you have your OS shell. So this is the shell that you use. You can use TC shell, CS shells, K shell, Z shell, fish, bash shell is probably what you're most likely going to use. And really what this is this is the interface that you're going to use that tells the operating system what you want it to do, right? To actually control it. Bash is what you're probably going to use most of the time. It used to be common like T shell or TC shell and stuff. I used to operate on the C shell and stuff like that. I haven't really in years, to be honest with you. I just haven't ran into it. Doesn't mean it doesn't exist. Doesn't mean that there's plenty of operating systems. When I stopped working for the DoD, I stopped using a lot of these old shells, and so some of them still are around. Obviously, it's just almost everything you see now has some sort of bash or variant of it, or just a shell or whatever. Doesn't really matter. Graphics server, right? This provides a graphical subsystem server called X or X server that allows programs to run locally or remote on the X windowing system. Now, one thing you'll know is when Linux is not known for its graphical, graphically sound components, right? In the sense of you're not going to see a lot of like heavy duty gamers using Linux. Nothing against it. It's just not designed for that, right? Linux is very difficult to make really complex systems work together unless you really, really know what you're doing. And so when that happens, and I know we said earlier that, hey, actually complex systems work really well together. It does on the simplistic basis. When you start getting like a GPU that isn't compatible and you need driver specific, but you need to also have them on Linux in specific areas and how the configurations change and all this stuff, you have to really, really know what you're doing. So understand that it's not typical. It is possible, but it's not typical to see really graphically intense computers running Linux if they're using it for that, right? Window Manager, right? Also known as the GUI, right? This is the one that actually lets you see a desktop environment. A lot of Linux servers don't have this. If you're looking at like Ubuntu and stuff like that, you're going to see that they have it, and it's really nice. But a lot of servers don't really have this. They just have command line. That's it. Utilities. Applications or utilities are programs that perform particular functions. So utilities are things that you're going to use throughout your day-to-day life, and then they work really well and they're efficient. All right, now Linux architecture. This is the nice thing. It's all a file system, right? So we have our hardware, peripheral device such as your RAM, hardware, same thing as any other computer, CPU, blah, blah, blah. Your kernel, this is your core operating system, right? It's used to virtualize and control common computer hardware. So it's used to actually tell that CPU, that GPU, all that stuff, what it needs done. You have your shell. This is how you interface with it. Then you have your system utility. This makes available to the user all of the operating system's functionality. So your system utility are the actual commands you run that actually tell the shell, right, is how you interface. It tells the kernel what you want it to do. Now, when I said everything's a file system, I quite literally mean it, right? Here is what it looks like. You have your bin, you have your boot, dev, blah, 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 all this all the way down. And keep in mind, anyone that's ever used Linux, multiple different OSs or versions, whatever you want to call them. Some people call them flavors, some people call them distros, some people call them OSs, whatever, it doesn't matter. They don't all have all these directories, so just know that. I actually used to know really, really in depth the directories, like what the history of them all and stuff. I don't really remember all of them, so I'll give you my best, of what I know of them. But just know that I used to know the history, and some of them, it is pretty fascinating, the history of Linux. If you ever look it up, it is actually pretty cool, because some of these you might say like this one, the etc file, right? You might say oh, that stands for etc. But the history of it, if I remember, was they didn't have a name or something. It's pretty cool. It's pretty interesting. I'm kind of a nerd when it comes to that stuff. So you have this / right? That's the root directory. This is the baseline for everything. You can see that's when they say Linux file system. This is like your C drive on a computer, on a Windows, right? It's everything. So it's the top level directory. If you go to the root, everything's below it. Then you have your bin, which is binaries, right? Contains several essential command binaries. This is where the main binaries are stored. Boot, obviously, what's it sound like? It's where most of your boot stuff is stored, right? The bootloader, the executables, blah, blah, blah. Then you have your dev, contains DEV, dev stands for devices here, not development. So just know that. Contains device files, to facilitate access to hardware devices. So this is where you're going to, if you have a USB or something like that you need to plug in. And keep in mind, the big thing about Linux is you can do anything anywhere. Meaning, if I plug in a device and I'm I don't want to mount it to dev, I want to mount it to lib or lib, right? Library. I can. You can do whatever you want. That's the nice thing about it. So just know that not every machine you get on is this going to make sense. You might get on them and be oh, I'm looking for devices, and you find them under home, and you're what the? That's not where it goes. Understand that it doesn't really matter. This is just what they built the directories for, right? So now you have etc. That's what most people call it. It actually, if you look at the initials, is etc., but most people call it etc. And this is your local system configuration files. Configuration files for installed applications may be saved here as well. So when you're looking for actual config files for the system, not for applications you download or anything like that, look in here. Now, home. Everyone that has a directory or that gets a user account on a Linux machine has a directory under their home or under home. And so if I had an account, it'd be stuffy. It would be under home, and that would be my home account. And I'm the only one that has access to that besides root. And so this allows me to actually kind of store my stuff. It's kind of like if you go to my computer users or, C drive users, that same thing on Windows. Library, shared library files that are required for system boot. Media, external removable media such as USB drives. So I lied to you before. I forgot about the media one because not every Linux distro has that. But devices, this is more of your hardware devices, whereas media is your external devices that are like media, like USB, SSDs, that type of stuff. So I do apologize, I had that wrong. Now mount, temporary mount point, right? So this is where, like, if you need to mount something to access it temporarily, like another drive or another hardware or hard drive or something, you can mount it here, and then you can do whatever you need to do with it, and then it's a temporary mount system, right? You're not permanently leaving there. You could, I guess, but then you have opt, right? Optional files. So this is where you have like your third-party tools. So like if I download or install something or use GitHub or any of that stuff, this is where you typically want to put them, just to keep it organized. Then you have your root. This is the home directory for the root user. So exactly like we talked about with the home directory for every user, this is the same thing, but for the root user. You have your sbin, which again for binaries, right? System binaries. That's what S, right? This directory contains executables for system administration. So if I need to run specific binaries for system administration, this is where they'll go. Temp. This is a temporary directory. So that anything that goes in here gets completely deleted and blah, blah, blah when you restart the machine. So just know that if you put anything in here, it's probably going to be deleted at some point. User contains executables, libraries, man files, etc. Then variables or var directory contains variable data such as log files, emails, inboxes, web applications, blah, blah. So this is your general general directories. Keep in mind you can have more or less depending on as you go through them. Now, Linux distros. So I'm not going to go through every single distro. You guys can feel free to read about them. Ubuntu, Fedora, CentOS, Debian, Red Hat. They're all very popular. Parrot OS, that's what the attack boxes are on here. Kali Linux is the attack box on whatchamacallit, Hack the Bot, or Try Hack Me, excuse me. That's probably why they don't have it on here, is because it's used by a competitor. But both are good distros for hacking. Many users choose Linux for their desktop computers because it's free, open source, and highly customizable. This is true. Most of people don't even realize Windows has a pretty hefty price tag just to have. It's $100 plus just to use it. You don't realize that when you buy a computer because you're paying for it with the computer, but if you go buy Windows, it's $100, right? Linux is free. You can see Debian is the most widely used and well-respected Linux distro, known for its stability and reliability. This is true. Parrot OS is Ubuntu, Debian, blah, blah, blah. And you can see, now they don't talk all about it, but you can go through and you can actually kind of pick your poison, if you will. Like if you just use Ubuntu, well, guess what? It's Debian, okay? So here's your Debian. You can actually download just plain Debian is what they're saying, right? You can use it. A lot of these are built on the back end of Debian, meaning if you go to like Kali or Parrot or whatever, and I don't know them all, so just bear with me. Ubuntu actually has a GUI and everything else, so it's a little bit different. But if you just use Debian, that's a Debian vanilla, if you will. That's really good, but understand that like Parrot and all them are built on a Debian backend. So all that means is they've kind of taken that Debian version and they've customized it to a way that they found suitable, and then I'm saying reselling, but they're not selling it. They're giving it away. But that's what a lot of Linux distros are, is just variations of a distro that basically they didn't like. They said, hey, it's open source. I like specific configurations. I'm going to configure this the way I want. And then if you like it, cool. And that's what Kali began as, when it became a hacking distro, was they put all the hacking tools and stuff on there, and people were like, oh, this is awesome. And they're like, thanks. Here, we'll just make it now, right? So, okay, introduction to shell. It's crucial to learn how to use Linux shell. This is true, and nowadays you see a lot of people using just like Ubuntu, the GUI interface, and they're like, I know Linux. Be careful, because if that's how you know Linux and you actually get to a location where they use Linux, then you're not going to know it, because if they use Linux and they use command line, like most servers only use shell, you're going to struggle. So make sure you know the actual shell, right? Terminal emulators, this is where you're going to see a lot of times it allows the use of text-based programs with a graphical user interface. They are also called command line interfaces. Basically, they're emulating the terminal, right? So imagine you're in a large office building where the shell is the main server room that processes all the blah, blah, blah. The terminal is like a receptionist desk that serves as a point of communication. Now, suppose you're working remotely. Terminal emulation software acts like a virtual receptionist. So what they're saying is you can emulate that terminal. It's not the actual terminal, but it will do what the terminal wants, right? So then you have your shell. The most common is bash, which is born again shell. Everything we do through the GUI, we can do with the shell, which is true. And you actually should, I actually recommend you do it through the shell. The reason I'm skipping through this is we're going to do almost everything on the shell here, so you might as well just see it. Okay, and you can see this. Okay, so it could be customized. This is true, but understand this is not necessarily default. But you'll see it'll have the one that they're going to present us with is going to have our username. Then it's going to have host name. And then the current working directory. That's just informational, so you'll see that. Then you'll have this $sign. Anything after that is what you're actually typing. So, and then you can see this little tilde, I think, and that tilde means you're at the home directory. So if any point you need to go home to wherever your default directory was, you just type the tilde, you say CD for change directory, and the tilde, and you'll go home. Okay, so this is what it looks like. They're the root user. They're on the machine hack the box, and they're in the current present working directory is / hack the box, right? And then they have here the hashtag, which all this does is you can see it means that we are logged in as root. Perfect. Unprivileged, $, privileged, hashtag. It's really important to see the difference because when you're working, especially on hack the box, sometimes you can get lost in where you're at, especially if you have a not a fully interactive shell and you are accessing the shell and you actually don't realize who you actually are at that point. It's really nice to be able to tell that. So the PS1 variable in the Linux systems controls how your command prompt looks in the terminal. This is actually kind of confusing if you guys use PowerShell, because if you use PowerShell, you read that, you're like, huh, what are they talking about? But the PS1 is what actually controls what it looks like. So you can add all these things is what they're saying. And you can make your shell list all the information for the computer right here if you want. You can dive into that if you guys want to. That's more customizable, more aesthetically pleasing. It's not necessarily something that you have to know. And you can see they have a bash prompt generator and power line, which gives us the possibility to adapt our prompt to our needs. Okay, so again, that's all aesthetically pleasing, and that's great. But getting help, this is kind of the bread and butter of Linux. You don't need this as much anymore, but like when I was working in data centers over a decade ago, right, you really, really needed to know this because you would run into this all the time, because data centers, especially for like DoD, you couldn't have cell phones, you couldn't have any of that stuff in there, so you can't look anything up. So we would have to use the man pages. That's what they're called. So you would see that they're typing ls for list. That's your first command, right? ls, it lists the directory contents, everything that's in there. And then you could see man, and then they're typing man, and then they just have a placeholder for tool, but we used ls, so they typed man for ls. Man stands for manual pages, right? So think about anytime you're like, hey, I need help. Think about, I need to look at the manual. That's the best way. I need to look at the manual. Type man ls, and you'll see it gives you the breakdown of everything on this page of how to use it, right? ls, it tells you how to use it. It tells you name is list directory contents, ls, the option, and then the file if you want. And then they didn't scroll down all the way here, but if you scroll down, it actually gives examples, shows like how you use it. So there's a ton of information in here. So I recommend you guys, if you're ever stuck, look at the man pages. They are a lot, but if you read through it, you will find, I almost guarantee you'll find what you're looking for on how to fix something. Yes, you can do this, tool / help. But understand, if you download third-party tools or use like GitHub pages and stuff like that, they don't all have the / help or the - help, right? And by the way, if you guys hear me call that attack, the dash, that is attack. That's what I call it. So I try to avoid saying it because people get confused, but that's what I call it. So you can see here they did ls tac help or -- help, and you get the same thing, right? It's a little bit different, but pretty much the same thing. Keep in mind, not everyone will have that, so understand both ways because you don't want to get stuck. And then the TAC H as well, which stands for help. Sometimes you'll do like a TAC H and you'll say, hey, we don't understand that command, and it'll give you a little bit of help, and it'll say use tac help. So just as long as you know kind of how to get help, you can find what you're looking for. I almost promise you that. Okay, so as we can see, the results from this is from curl. Okay, from each other do not differ in this example. Another tool that can be useful in the beginning is a propos. Each manual page has a short description available within it. This tool searches the description for instances of a keyword. So if you know, hey, I have like something specific I need to look for, it can actually do that for you, right? So you can see they typed in sudo, and here it searches the contents and gives you kind of a brief description. Pretty easy, pretty self-explanatory. If you need help, if you have access to the internet, you can find the help as well. So don't die on that hill, right? Okay, so this one, it's starting to show information. So let me go through here and start the targets while we talk about it. Okay, so we're going to go through basic information here, right? We're going to go through who am I, displays the current username. ID, this returns the user identity. Host name, set or print the name of the current host name. Uname prints basic information about the operating system. Okay, so far pretty simple. One thing I will tell you, and I've talked about this in my previous one as well, is you don't need to memorize all these. Look at this. Oh, look at that. I can copy and paste that and keep it as a cheat sheet. You don't need it. There's cheat sheet up here. You don't need to memorize everything. Linux comes from using it over and over and over again. What that means is if you use it over and over and over again, you won't have to memorize these because you will memorize them on accident. I promise you. I can promise you you're going to use these enough in your career if you're in cybersecurity that eventually you're not looking at that cheat sheet anymore. But until then, keep that cheat sheet right here. Who cares? All right. PWD, present working directory. ifconfig, used to assign or view an address to a network interface. Okay. IP's utility to show or manipulate routing. So some of these are old school, like ifconfig. You can still use it. Netstat shows network status. SS, utility to investigate sockets. PS shows process status. So this is where if you work with Windows a lot, you may be like, oh, that starts a PowerShell. Nope, that's processes. Who displays who's logged in. ENV prints environments or sets and executes commands. Okay. LSBLK lists block devices, lists USB devices, lists open devices, lists PCI devices. All great things, but again, don't die on this hill and memorize them. I promise you won't need to. You can look them up at any time. Okay, you can see here, secure shell. So they're talking about SSH, which is actually it's called secure shell, but it's a way to remote manage this server or computer, whatever you want to say, and you log into it using secure shell, and you actually have a shell now with an encrypted channel where you can control that shell, right? So that's really what you're doing here. All right. So they're telling us how to use secure shell. Then they're telling us, hey, let's check host name they've got Nix Fund. That's what the name of it is. Who am I? They got Cryolite, I guess. ID, and you can see you get the actual user ID, you get the group number or numbers and all that stuff. So you get, and then they have Elite Hack the Box. Okay, so you can see the ID command expands on who am I. Who am I is the simplistic version. If you just take over a box or something, you're like, I don't know who I'm logged in as. That's where you're going to use who am I, because you're just like, I just need to take a quick check. ID would be you need more information than that, right? So this can be of interest to a penetration tester looking to see what access a user may have, right? So you can actually see their group ID and all that. In this output, hack the box group, boom, with the elite is of interest because it's non-standard, right? When they say non-standard, it means it's not normally there. Someone created that group. That means they probably created it for a reason. You probably have some additional permissions that the other groups don't have. The ADM group means that the users can read log files and var log, potentially get access to sensitive information. Perfect. Membership in the pseudo group, is of particular interest because that means you can run things as admin, which means you can probably become admin. Okay. All right, uname. So let's dig into the uname command, and you notice they typed in man uname, so they're actually looking at the man pages. And they get all this information. Great. And they say uname tac A. Well, if you look here, uname tac A says print all information in the following order. And you can see we've got Linux box 4.150 generic, number 100 Ubuntu, SMP, blah, blah, time, architecture, all that stuff. So you get a lot of information about the system. Awesome. So we've got the kernel, we got the host name, we got the release date, the release, which is really important because we know now what security updates do they have. Well, we know because of that's their release, the kernel version, all that stuff. So now, suppose we want to print out the kernel release to search for potential kernel exploits. Well, you can type in just uname tac R. You don't need the uname tac A, right? Okay. With this information, we could go search for that exploit and first result, and we could take over that box. That's what they're saying. So let's go ahead and dive into it. So it says SSH into this machine, right? So just copy that. I'm going to make this full screen because I know it's a pain in the butt to see that. And we'll make this bigger for you guys. And we'll say SSH. I don't know if they gave us a user. Hack the box student. Okay. So hack the box student at. Okay. It didn't copy. So 10.129. 237. 44. Okay. And then the password is hack the box academy student. Let's see if I can actually get to copy and paste. Yes. Did it work? It worked. Okay, we're in. And you can see we're Nix Fund. So find out the machine hardware name and submit it as the answer. So two things you can do here before we dive and start doing this. You can look at the hint, right? And it'll say, take a look at the uname utility, right? So, or you could go up here and find right here, uname. And if you remember, you can actually do this one. Where is it? The hardware name is tac-im, which is what they're asking for, right? Find out the hardware name. So we can say uname tac-im, and we get x86_64. There you go. What is the path to the Hack the Box student's home directory? Well, one thing we can see here, we can see that tilde. That means we're in the home directory. So now we just say pwd for present working directory. And there you go. Home, Hack the Box student. The other thing is you can also assume that based on when we were going through the module, it said anything after home will be a user's home directory. So we could assume if we know our username, there you go. What is the path to the Hack the Box student's mail? Well, this one, if you remember going back to var, right? We know that the variable here stored our mail inboxes. So you go cd mail, and cd, by the way, changes directories, right? And you can see this one would be our username if we had one, right? So we say, and it looks like, funny enough, this one actually says it, but there is no mailbox in there, which is fine. They may not have anything set up there, but that's where it'd be based on what we learned before, that everything's under the variables or var, right? And then var mail. Now, which shell is specified for the Hack the Box user? So let's go back to home, right? And we already said that bash shell or bin bash, which is born again shell, that's going to almost always be what we're kind of working in, especially in Parrot. And we know that this is Parrot OS, so it's safe to assume it is bash. Now, here's the thing. A lot of people get on my channel and they'll say things like, well, how did you find that? I'll be honest with you. I didn't, because I don't need to, right? And I don't mean that insultingly. I mean, if I am confident that I'm using, this is Parrot OS, right? Which I am, because that's what they use, and or at least last I checked they use, right? And I'm confident that Parrot OS uses bin bash,
I can put it in there, and if it works, awesome. If not, then I will go find it. The reason I do it this way, because I understand this is not the way the box is necessarily intended. I understand that you guys are going to say, well, you were supposed to go here, and that's how you find it, and you just guessed, or you cheated the system, or whatever. That's what hacking is, okay? Understand that hacking is just doing something differently to get a result, right? If I want to take over a machine, guess what? The intended way to do that is log into the machine. I don't want to do that. I want to do it a different way. So I'm doing unintended things using the system, right? So understand, I have no problem if someone's like, I don't know how to find this. Let me put it in. Why? Because that's just problem solving. Meaning, if you said, okay, don't do that, you could probably figure it out, right? So understand, if you see me do that, don't assume that I can't figure out. I could go right now, hey, how do you Google what's the way to find the bash shell, or find the shell on the machine, right? Super easy. It would tell you probably check bin bash, right? Okay, cool. Or I could just take the knowledge I have, explain it, and then attempt it, right? So which kernel version release is installed on the system? Well, going back up here, we're looking for the kernel, and you can see S is the kernel name right here. Uname tac S. And I didn't mean to do the additional. Okay, so the kernel name is just Linux. So we're looking for the kernel release or version, so V. And we could do A for all. Okay, that's Ubuntu. So what is it asking for? Because I thought it was the kernel release, okay? Well, let's just do all then. All right, and there it is. 4.15.0.123 generic. I must have typed it wrong. 4.15.0. There you go. And yeah, I probably just typed it. Yeah, I did V instead of, I did version instead of release for some reason. Okay, and then what's the name of the network interface? That MTU is set to 1500. Well, if we go up here and we look, we can look at IP, right, or ifconfig. We can look at either one. All right, ifconfig, and we're looking for the interface, which there's MTU 1500, which is what it actually said, and there's the interface name, ends 192. Ends 192. Perfect, easy enough. Let's go on to the next one, right? Okay, so this is called workflow, this section. So navigation is essential, right? So how do we get around? Personally, this is kind of where you lose me a little bit if you're try hack me. Hack the box. I've talked about it before, but they have really good content and they do stupid stuff with it. Like this one. You're now going to teach me present working directory, ls, cd probably, etc. But you just made me have to do all that to get the answers to the previous section. So if I was here, I'd be lost. But if I go through this navigation first, then I understand how to get around, then I'd figure it out. So if you're doing it that way, I apologize. I didn't make the box. I'm just reporting on it, right? Okay. So now you have PWD for present working directory. We talked about that. LS, it lists the contents, right? Excuse me. The ls tac L option to display more information on these directories, right? So it displays, the permissions. Actually, it shows it right here. So the permissions, and we'll talk about these permissions as we go on. Then it displays the number of links to the files, right? Then it explains the owner, then the group owner, then the size, and then the date, and then the desktop. Or sorry, the directory name, right? So what directory is it? Perfect. Okay, so again, do you have to memorize that? No, you'll use ls tac la enough times that you'll probably, and you can see there they actually mentioned the la. That's typically what people are going to do because it shows hidden directories. Anything with a period in front of it means it's just hidden, right? This is very common for system files and stuff. Windows does the same thing. You don't need to see everything. So use ls-tach-la and you'll see these hidden files as well, these period files. And there's nothing wrong with seeing them or not seeing them. It's just you need to know that that's how you find them, right? Okay, so to list the contents of a directory, you don't need to go into the directory, meaning you can ls a remote directory, right? Or a directory that you're not in that current directory, and you can still list the contents just fine. Okay, now cd, change directory. cd, change directory. Just try to remember it that way. If you can't, no worries. It takes 2 seconds to Google that, figure it out. We can quickly jump back into the directory we were last in by cd space tach, right? That will jump in the previous directory. So if you went to a directory, you're like, crap, I need to go back, cd tach, you're back, right? Now, you can do this, cd, whatever, start typing, and then tab, and tab will autocomplete, meaning it will actually fill it out automatically for you. If there's multiple, if you hit tab twice, it'll show you the options, right? So if you're like really deep into a directory and you're like, I don't remember the exact path, I can hit tab twice, it'll show me the options. It's very nice. If we add the letter H, right? So all they're showing here is that it's going to autocomplete versus show the options. That's what they're showing. Now, cd period period. This is really important because a lot of people know that cd period period takes them back a directory. They don't really understand why. And I think it's really important. So we will go here and show it. So here's the big thing. If I say ls-tach-la, right? You can see every directory has this period period and this period, right? The period 1 is the current directory you're in. Remember, we said everything is a file, everything. That means the current directory right now is this file right here, right? This period period is the previous directory. So when you're saying cd period period, you're actually referencing this right here in the directory and going back. So it's important that you understand why. I don't think it's necessarily important because I think it adds a ton of value. I think it's important because if you don't understand what you're doing, you're just kind of doing stuff and you're not actually growing. So that's just me, right? Okay, now they're showing you here, since our shell is filled with some records, we can clean them out. Yeah, that's great. They're actually going to cd into this shm, and then they're going to hit clear. So if you do and, it's just going to say run this command and that command. So they're actually just saying change directories into this and clear it out. That's all they're saying. Okay, what is the name of the hidden history file in the Hack the Box user's home directory? Well, lucky for us, we actually just went in here on accident, right? So it's .bash history. Now, that bash history file, actually, funny enough, if you open it, cat.bash history, well, the only history they have is exit, but it stores the history of your commands you're running. Okay, now what's the index number of the sudoers file in the etc directory? Okay, the index number, so we'll just say ls-tach-la, and it was sudoers file in the which directory? I didn't etc. We don't even need to do that. We can just do that, right? And we need the sudoers file, right? And okay, and let's make sure. What's the index number of the sudoers file in the etc directory? Okay, so we found it. Now let's just cd into it. Okay, and now let's go look at that. I hate my mouse, by the way, because I don't know why it does that, right? Okay. And this is, so I think I had this problem with Hack the Box or before, is it says stuff like this. What is the index number of the sudoers file? So let's say how command to get index number Linux. And it's really annoying because they didn't show you that. Okay, and it's tach I. So they wanted you to go and actually say ls tach, and I'll show you guys you can do ls tach ALA and I, and you'll get it all. and you get the index number plus the permissions. But it's, and by the way, that's how quick a Google can be. Do I memorize the index number command? I do not. So here's a sudoers file, 147627, 147627. Boom, easy enough, right? But it drives me nuts because what they're trying to do, I understand. They're trying to make sure you actually read the man pages and stuff like that, but don't walk people through it as if this is all the information you need and then go, gotcha. Like, say, you're going to need to review the rest of this or you're not going to be able to answer these questions or something, because they do this all the time. They display all the information and the questions don't make sense, and it drives me freaking nuts. Okay, so now working with files and directories, create, moving, and copying. So touch, if you've never heard of touch is a command that in this case, they're going to probably use it to make a file, but it actually just physically touches a file, meaning if I go and look, all right, so if I go look right here, this file xdg, well, that's a directory, wget-trc, right? See the date, April 8, 2019. If I have permissions, which I don't know if I do, wget-rc, right? And I touch it, yeah, I don't have permissions. So we'll go cd home, I'll have permissions to anything in here. And I say touch, you notice the bash history says 5 September 23. I'll say touch bash history. And now when I do it, the bash history has today's date. It literally just touches it. If you notice, I'll say cat bash history. Nothing changed inside of it. It just literally touches it so that that date changes if you don't have it, or if the file exists. If the file doesn't exist, it creates one, an empty file with that name. So understand that. Now, a lot of people do that to, like, if they want to just create a file that they're going to put stuff in or whatever later, they'll use touch. Now, mkdir, make directory, right? This literally makes a directory, whatever name you want. In the current directory you're in, it will make that. So in this case, they're going to use a file called info text, touch info text, make directory storage, and then they're going to say, when organizing your system, you may need to create multiple directories. So here they're going to make a whole directory tree, which it looks like they're going to make storage, local, users, documents, and then I'm assuming they're going to put that file in there. So yeah, so they're saying make dir, parent, storage, local, user, documents. Okay, cool. They're showing you a breakdown here. This is what it's going to look like, right? Info.txt, that's the file they created. But then they created storage, local, user, documents. Now, when they actually go through here, you can see now they went touch and they went all the way through storage, local, users, info.txt. It will create that document. Now, when they look at the tree, they have info text because that's the one they originally created, the storage, local, user, documents, and then inside that is the info.txt. Okay, now with the move command, mv, right, we can move and also rename files and directories. Okay, so they can move. In this case, I'm going to skip the syntax and show you mv, info.txt, and information.txt. So all they did here is rename that file. It looks like they are moving it, but they just renamed it. They just said move info.txt to information.txt, which is just renaming a file. Now touch readme.txt, they create it. Then they said, hey, move information.txt and readme.txt to storage. Now if you look, go into the tree, you have storage, information.txt, and then here's your readme.txt, right? So it just moves them to whatever contents you want, which in this case was storage. Okay, now CP, copy, right? Storage readme.txt to storage local, and then it'll change it to local readme.txt. So you can see if you look at tree, they said storage, and it used to say storage readme.txt, right? And now it says storage, there's the readme.txt, but then under local, there's a readme.txt because they CP copied it, right? All right, so now what do they want us to do? Let's see. What is the name of the last modified file in the var backups directory? I don't know what that has to do with the copying and all that stuff, but we'll take a look. So we'll say ls tac la, and it was, what was it? Last modified file and var backups. Var backups. And you can look at the date, and this is November 11th, November 12th. There you go. Let's see what the answer is. APT extended states. Yep. And the reason that is because you'll see there's actually, where'd it go? There's actually right here 2 things that were edited this date, but one of them is a zipped file and one's an actual file. So they're saying the last modified file, it's that one, the APT extended status. What is the inode number of shadow.back? Like, what do they talk? Like, here's the thing. No problem with them doing that, but how do you go from, hey, here's how to copy and move files, to what is the shadow.back file? What is the inode number? Well, let's see. What command for inode number on file Linux? And we'll find out. Okay, so ls tac a, we're back to it. All right, so we'll just say it's under var backups. ls tac I var backups, and we're trying to figure out the shadow.back 265.293 265.293. So questions had absolutely nothing to do with moving files, copying files, any of that stuff, but there's your answers. Now, editing files. This is where it gets a little more complex because of the fact that Nano, VI, Vim, all of these text editors that Linux has are a little bit more complex than like your Microsoft Word or something like that. They're very easy once you figure them out, but a lot of times they take like cheat sheets just to get used to it. So Nano is what they're showing us here. Nano notes.txt. So here they're opening a file called notes.txt, and they're going to make their notes. They're going to type just like a regular text editor. And you can see they have these Control G, Control X, Control all that stuff to actually move the cursor around and all that stuff. You can use the arrow keys as well. There's a lot of different shortcuts here, basically, right? And then you can see the caret stands for control. Yep. And then if we press Control W, that is where is. That's a search. And then you can actually search for something if it's a large file, etc. All right, here we can type everything we want to make our notes. Search and it shows you where it is. Okay, after we have saved the file, we can leave the editor with Control X. Okay, so you can save the file by hitting Control 0 or Control O, excuse me. So again, just know these. You don't have to memorize these. Just look up the Nano cheat sheets. There's all kinds of them. Now you can see cat notes. Once they edited it, they actually catted it. And there you go. Their notes just say, here we can type everything we want, make our notes. You can see that there's a lot of text here, but all they've added is this part, right? And that's all you're going to see in the actual thing. Now, historically, the Etsy password file also stores the password hashes. It does not. It stores the shadow, or the shadow file stores the hashes. They're saying historically it used to. So no, the Etsy password just has the users in it now. Okay, now Vim. And what they're saying here, the Etsy password file, the reason it's so useful for people is it's globally readable. And so that means that any of us can actually go read it, which means if I'm testing, if I can get access to a machine or something like that, that is a known variable that won't change, and I can read it. I can always reference it, and I will know if something worked. That's really what the big value is in it, besides the fact that you get the user accounts. But okay, Vim. So Vim is modal, gee, mini Christmas, is a modal editor that can distinguish between text and command input. Vim offers a total of 6 fundamental modules that make our life easier. This is true, but keep in mind, if you don't know how to use Vim, you're going to need a cheat sheet for sure. So normal mode, all inputs are considered as editor commands. So this is how it starts up. It's going to start up. It's going to be thinking everything you're typing is a command. You have to type I or hit I, right, to insert, and this is where you start typing stuff. Visual mode is used to mark contiguous part of the text, which will be visually highlighted. And then command allows us to enter single line commands. And then replace, this is exactly what it sounds like. You're going to replace stuff. Then EX emulates the behavior of the text editor to exit. Vim tutor, right, is something to practice with the editor, because nothing screams use my text editor like I had to create a tutorial for you to figure out how to use my text editor. Don't get me wrong, Vim and VI have been tremendous in my career. I love them, but there is a learning curve. I use Nano unless I need to use Vim or VI for something, right? So understand that. There's no questions on that one. Let's keep it moving. Okay, find files and directories. This is going to be one of the most vital things that you're going to probably do, and that is finding files and directories. So one of the things, how do I know if something's installed? How do I know if I can use it, right? Well, which, that's the word, right? One of the common tools. This tool shows the path of the file or link that is executed, right? So if I say, when I type Python to run a Python script, what's running? When I type curl, when I type netcat, when I type cat, when I type ls, what's running? It's going to show me that path, right? That's really important, because guess what? What if I'm trying to use Python, but it needs Python 3? And every time I type Python, it's not going to Python 3, but I have Python 3 installed. I need to change how I do it, right? Or I need to directly use that. Now, find. Find is exactly what it sounds like. It actually finds the files. This is where it can get complex. Look at that find command. You might say, whoa, that's way more than I thought it was. Well, guess what? It's not that hard. It's just hard to understand initially. So find, they're using the root directory. That root directory means search the whole computer, because that's where it's going to start search. Type is F for file. I want to search for a file. The name, I want it to be a wildcard, so anything .config or .conf. So any config files on the root directory that are a file, that the user is root, the size is plus 20K, right? And then, I don't know, newer than 2023.3. I don't know the date on this box, so I don't know how old that is. And then execute the ls, a L command, and then this gets confusing, but the 2 dev null, this tells it so when you run any type of command and you're not root on the box, you're going to get errors when you're searching the whole box. You're just going to get errors. You're going to get permission denied all over because you can't access those files. So you do the 2 dev null, because 2 is an error code in Linux, and it sends it to dev null, which means just don't show them to me, get rid of them. And so it prevents you from having a screen full of errors, and you have to go through and try and find these, the files in there. Now you look, and you can see now you have the autoconf, the tri-state conf, the repeats, all these. So now you have all the configuration files. That's a long way of saying exactly what I just said. They laid it out for you because they executed on there the ls. That's why you have the permissions here as well. So really good one-liner here. If you've never used this, save it in your notes. Just change it for what you want, and it's a really good way to locate stuff and find files on your machine. Locate. It will take much time to search through the whole system for our files and directories to perform many different searches. The command locate offers a quicker way to search through the system, in contrast to the find command. Locate works with a local database that contains all information about existing files and folders. Okay, so you can update the database. Sudo update database, right? If we now search for all the files with the conf, right, you will find that the search produces results much faster than using find. Yeah, it does, but you have to keep that updated, right? If you don't keep it updated, doesn't matter. Now, it's funny. There used to be a trick, and I bet you any of you Linux admins out there, people used to do this themselves. They would take an entire backup of the names. I've done it a few times, and I used to do it when I was a Linux admin. You would take a complete backup of all of your names of your files and stuff and store them in a file like that. So then you could use something like grep and just quickly search for them. And it was not the best thing, but I'm glad they've added the locate to actually get rid of that functionality and save us the time. Now, what is the name of the config file that has been created after 2023 and is smaller than 28K but larger than 25? Well, we can just take this little one-liner here, go back down, and we can say, we'll just do it right here if we can. So we'll paste this, okay, and we'll say, what is the name of the config file that's been created? So same thing, created after 2020, So we don't need it to be any user. We need it to be smaller than 28K but larger than 25. Okay, so smaller than 28K but larger than 25. So let's just do plus 25K and just see how many we get, right? And same thing. Let's see how many we get here. So, all right, so we're getting a decent amount. All right, there's our file right there, Mesa defaults. So we could just stop there. There's only 4 to search for, or 5. But all we would do is say we want it to be plus 25K and less than 28K. And no, that didn't work. All right. We'll just do this. Size 25K, 28K. Let's see if that works. It might just be 25 to 28K. That didn't work either. That's all right. We found it here. I could just go through, I just Google this real quick to see the size parameters, or I could use the man pages, but we found it anyway. There was only, so this is a little trick I do to save myself time. If I don't know the command right off the top of my head, I will actually just run it if I know it's only going to produce a handful of results. And there's only one file that's different than the rest. There you go. And I would put that in. Now, does this work every time? No, but if I'm like, and sometimes it bites me in the butt because it wastes my time, but it's better than me going and putting this in here. And to be honest with you, nowadays, all I would do is take this, put it in ChatGPT, say, hey, I want this to give me plus 25K. I probably, if you want me to be honest with you, the way you probably have to do it, which is really annoying, which is why I didn't do it, is size plus 25K. And then you probably have to do size less than 28K. Isn't that what it said? Less than 28? Smaller than 28K. And then there you go. So for those of you that were probably watching going, oh, he just doesn't know how to do it, I could have figured it out. I was just trying to take a shortcut there. So there you go. How many files exist on the system that have the back extension? Well, let's just do, we can get rid of pretty much all this. You can leave the execute ls tech la, it doesn't really matter. And we just want the dot back. And one thing you can do, you can just count them if you wanted, but what you could do is go word count, tac L for lines, I believe. 4. So there you go. So all I did there was put the pipe. So anything that, all the results from this go into a pipe, and then it feeds that into this command, which is WC, stands for word count. And then I did tac L for lines so that it counts all the lines and then presents the answer, which was 4. Submit the full path of the XXD binary. Okay, well, this one we could just say, get rid of the find, and we can just do, instead of the XXD. Now, I understand what they're wanting you to do is probably do the which right there. If I was seeing if that would work. So which in XXD, user bin XXD. Very, very easy. I was just curious if it was a, well, I should have taken the dot out of there for one, but all right, let's see what we got next. So file descriptors and redirectors. Okay. So this gets a little bit more into the weeds here, but you have your file descriptor, which is a reference maintained by the kernel, allows the system to manage input, output operations on the actual hardware. So it acts as a unique identifier for an open file socket, any other IO sources. So you have your 1, which is your data stream for input, std in. You have your std out for output, and then you have your data stream for output that relates to an error. Remember we talked about 2 being the error code? There you go. So you can actually specifically say STD in, STD out, that type of thing. And you can see when they cat, think outside the box, they get think outside the box. And they're showing you here that the STD in FD0, which is the input, that's the input they put, marks it as green. And then the output is 1, which is this red, right? And there's no errors in this case. So here, find Etsy nano shadow or name shadow, and you notice they're going to get this find permission denied, permission denied, permission denied. That's your error. That's your STD or error, excuse me, FD2. So that is going to be your error codes. So how do you get rid of those? The to dev null trick that we showed before. Here you go, to dev null, real simple. Redirect STD out to a file. So this is very common that you're going to say, hey, find Etsy name shadow to dev null. And you can put a caret there to redirect it into a file. So anything it would have outputted, it's going to put into a file for you. So that way you don't have to wait for it or whatever. You can run it in the background. You can go do whatever, or you can just save it, right? So find Etsy name shadow to, so any error codes put into the std error.txt. Any of the out or input put in the std out.txt, or the output, I'm sorry. The input's 0, the output's 1. So what they're saying here is you can specify, you can say, give me the errors in the error file, give me the output in the out file. And now when they look at it, see how it has them separate? So you can actually break it down to that level, which is really, really nice on Linux and really, really useful. Now, this is kind of an interesting one, right? So we've seen cat, right? Cat, whatever command, it opens a file. Well, here they're showing you, this is what it actually does. Cat, the caret points to cat, std out.txt. I want to feed the std out into the cat command, right? So it looks backwards, but that's really what it's doing anyway, excuse me. Now redirect std out and append the file. So we can say find Etsy name password, and you notice there's 2 carets. Before there's only 1. Now there's 2. That means add it to the end of the file, append it, right? So now the std out and then the to dev null. So now they said, remember we already did it once. Now they want to add stuff to the bottom of the file. So now redirect the std in stream to a file. So a stream is until it sees this end of file. That's what they're showing here. So cat, everything until they see end of file, everything feed into cat and then feed out this stream.txt, right? So anything he types, it's going to keep adding. It's just going to keep a stream going until it sees EOF, end of file, right? That's what they're saying. Now the pipes, we talked about this before. You take everything here, the whole command, any of the output, and you pipe it into the next command, which in this case is grep. Grep is a search function, and it will search for the system MD. So all the results, all you see is the ones with system MD. Then you have your file descriptors and redirectors. Okay, so you have find, same thing. We're grepping it into the system MD, and then we're doing word count tac L for lines, the same command I did already, and you'll see you get 6 lines. Same thing as here. You just don't see the results. You just get the lines. This is really useful. The word count is really useful when you're doing like a pen test and you need it to show proof of concept, but you can't display it because it's sensitive information. You can do word count on the file. The company can prove what's in that file, and you can show, yeah, this was here. So how many files exist on the system that have the log file extension? Well, let's do this. So find, we'll do this. We'll say, and I really could get rid of the execute, but it doesn't really matter. The log extension. Whoops, I did that. Okay, log extension, and we'll go ahead and say word count tac L, and we'll let it run. And 32 is our answer. So we piped it into word count. There you go. And you have to make sure you do the tac L. If you don't, it's just going to show you all the words, and there's going to be a lot more words than just 32, but that's the lines. How many total packages are installed on the target system? I don't even remember how we did that, or how they, let's just say, what command shows total packages installed on Linux? Okay, so, and you can see right here, we'll see if this actually works. You can see they're using grep tax C for count, but that's okay. We'll see if this works. May not work. Yep, it did not work. And that's because package wasn't on there. So we'll say, there we go. So apt list installed, and we'll see they're using word count list again, 738. So there you go. So they're just using apt. If you haven't used apt before, apt is the program, like you'll see a lot of times sudo apt or sudo apt get, whatever, sudo apt get install. These are the program that actually installs packages. And you can see if we look in there, well, this says 738. So actually kind of interesting because this says 737, but all right, guys, welcome back. So we're going to talk about filtering contents now. And yes, it is I had to stop recording, so that's why I'm wearing a different shirt. So I had to stop recording and come back to it. So first thing is, the biggest thing with Linux that I see people struggle with isn't the getting around day to day. They figure that out pretty quick. Just using it for a little bit, you kind of start to figure that out. Where you start to struggle, where you start to see those people struggle, is you're going to see them struggle with like, okay, I can't just control F and find stuff, and they're on like you can on Windows, and they start to struggle when they are like, hey, I need you to deep dive these logs, and they're like, well, I don't know how to do that. Like, it's that filtering contents and this is where you're going to probably get the most bang for your buck from this module. So the first thing is the more command. Okay, so the more command is used if you have like, so you're going to see when you get into Linux, since everything is a file, some of those files get really long, like really long. And what you need to do is you need to be able to parse through it. Well, the more command lets you actually go through it. So I'll show you if we go here and we say cat etc password, you can see it's not super long, but I do have to scroll up, right? Nothing crazy, but I do have to scroll up. But then if we go over here and we pipe that into the more command, we can say cat, we can just do that, etc password, and say more. You notice it says more at the bottom. It only shows me the lines that fit on the screen, and then I can hit space and it shows me the rest of them, and I can hit space and it shows me the rest of them, and it goes line by line, right? So you can actually do it that way. So the more command is super useful for that because of the fact that you're able to actually go in and kind of go line by line. This is really nice if you're looking for something specific or anything like that. Now, it does show 10 lines by default. You can change that. Or I'm sorry, not more. I was thinking about head. Excuse me. More command does not show 10 lines by default. It shows what's on the screen, and then you hit space or whatever, and you can keep going down the line. Now we move to the less command, right? And you can see if we now take a look at the less, we'll notice that on the man page that contains many more features. This is true. So most people use less rather than more. Sounds counterintuitive, I know, but a lot of people use less. It's almost the same thing. It's just less has more options. So it's up to you what you want to use. If you want to see it in action, we'll just do the exact same thing, but say less. And you can see pretty much the same thing. The difference is I have this little colon down here where I can use all those options. That's pretty much the main difference, okay? So up to you which one you want to do. It says here, when closing less with the Q key, we will notice the output we have seen, unlike more, does not remain in the terminal. So it gets rid of the terminal. It gets rid of the output, which is nice. Can be nice. You might want it. I don't know, but I like it. So that we move to the head command. This is the one that head and tail is one that you're going to use quite a bit. You use the less and more quite a bit, but usually you're going to use one or the other. You're not going to use them both. Some people do, I guess, but I've never seen someone that's like types out more and then 10 minutes later is using the less command because they do the same thing. So the head command. So the head command is going to show the top 10 lines. When I say top, whatever's at the beginning of that file, those 10 lines, that's what it's going to show. Now you can change it. So if we do this same thing and we say head, right? We're only going to see the top 10. I could change that and say I only want to see TAC 5. And now I only see the top 5, right? So you can change that. But the reason you do this is, let's say you know that you have this really long file, but you're like, I need to get to the top of it. I need to see the beginning of it because there's something at the beginning, right? This is what this is for, right? The other reason you do this is the big one you're going to use the most is tail. And the reason I say this is I've seen this almost exclusively used by people when they're looking at logs. When you're looking at a log of anything, right? An Apache server or anything, right? As you're looking at that log, logs are coming in, right? Tail allows this to have the stream open, basically. So what that means is you can use the tail command on your log file, and you can watch those logs come in. So if I'm trying to troubleshoot something, I can have tail have that last bit of the files, right? And you can actually do that. Now, I will tell you, and let me make sure, I don't want to talk on my butt, but let me make sure. Tail command Linux, does it show live results? Let's see if that's the right way to say it. Yeah, so you can see you can use the F follow option, and it will allow you to track updates in real time. So that's pretty much what I've used it for, is logging or logs. And the other thing is, like, 90% of the time when you're troubleshooting something, understand that it probably just happened, right? That's why you're troubleshooting it. So when it just happened, guess what? It's probably one of the last things in the log. So use tail to try and see the bottom of that log, and see what's going on. Now, tail and head, they have use cases, but as long as you know they exist and you can find them pretty quick, you'll be fine. Now, sort, right? So the sort command, this actually sorts depending on which results and files are dealt with, they are rarely sorted, okay? Often it's necessary to sort the desired results alphabetically or numerically. So if you look, when they did put the etc password in sort, if you look over here, it's in alphabetical, right? So this isn't really useful in this use case, but there's a lot of times where I know I'm looking for a file that starts with a C, for instance, but I have a list of 10,000 files. Well, this is going to take me all day, right? I could grep it and do different things, but just sort them, and then you can look at them alphabetically. And you can keep in mind, you can combine as many of these as you want. So, like, for instance, I can say cat etc password head sort, and you can see it's still going to put them in alphabetical and only show me the top 10, right? So you can put them in any order you want. You can combine them. You can do a bunch of different things like that. So then you have grep. Grep is one we've talked about already, but this is a search function. So if I'm, whatever the output of this is, so in this case, I'm opening the etc password file, I can search for, in this case, they're searching for bin bash, and it will show only the results for that bin bash. This is probably the most common search function that you're going to be using, mainly in Linux, because of the fact that 90% of the time, with everything being a file, it's really big, and you want to make sure that you have the capability to find what you need. And grep is huge for that, and we're going to see that here shortly. Now here, they're using grep tac v. This means everything but. So, for instance, the false no login, if you look, they're saying, give me everything except what has false no login. So if this line exists, don't show it to me. And so that's what they're doing here. So it's the inverse of grep, right? If let's say I have a log file and I'm looking for only things that were not successful, but there might be other errors in there as well, I could do grep tac v and put success, and it would show me everything that isn't successful, any other errors, right? Cut. So cut is something, this is where people get a little bit wonky or confused, but once you figure these out, this will save you so much time. So here you can see they kind of combined them all, right? They said same thing as before. Cat etc password, show the etc password file, grep that into a v, which mean, or into tac v, which means show me everything that's not the false login. So the output should look exactly like this at this point. But then they said cut, and they did tac d, which stands for delimiter, and they put this semicolon. So they're saying cut and use the semicolon as the delimiter, the spot where I want to start cutting, right? And then tac f1 stands for field 1. So this is the first field. So show me everything in the first field and then cut anything after this delimiter, which is the colon here. So all I get is the actual users. So this actually is very useful because there's a lot of times where you get on a machine, you're doing a pen test, whatever, and you don't want all this extra data because you're using, for instance, the Etsy password file. This is a perfect example. I'm only using it in this case to look at users. Well, I don't want to scroll through the users and look at all their home and directories and all this other stuff. Not yet, maybe, or maybe I don't really care. Maybe I just care about the users. So I can say cut delimiter. Here's all the users. And then I can also use that to show proof of concept that, hey, I did get the Etsy password file. I was able to take over the machine, at least as a user. Here's a list of all the users. And you didn't give any extra data away, right? Now, tr command, right? So this one has the possibility to replace certain characters from a line with a character defined by the tool. This is really useful for certain things that we're going to show here shortly. And so this is really useful for things like, hey, maybe like this case right here, they're replacing that semicolon, this semicolon right here, with a space. Why is that really useful? Well, look at how, if this is a huge file, look at how difficult that would be. So like we'll say cat Etsy password. Now it's kind of hard to make heads or tails of it. I mean, if you know what you're looking for, yeah, it's not super difficult. But if you had a ton of information in here, it's kind of hard. So if you say tr and you want to replace the semicolon with a space, now it separates them a little bit. Now, that might not look like a ton of help, right? But what if I did it this way? What if I said, hey, I want to do the semicolon as a new line, right? I want to replace the semicolon as a new line. Now, this is going to be a huge file, and you can see, oh, just put that in there because I didn't do it right, but that's all right. You can see it replaced it with the, there we go. There we go. I replaced it as a new line. Now, you might say, well, this isn't helpful. Maybe not on this use case, but I'm showing I can manipulate this data however I want, right? I could say every time a semicolon happens, I want a new line. Well, that's great because now if I wanted to, I could continue and grep for something specific. So you can see that I can actually use this quite very, very intelligently to kind of really start filtering out my data the way I want. This case, they're just showing the space because it's a simple, easy way to show it. Now the column, this one I haven't really had to use too much. Maybe it's just because I've never cared too much about the columns, but it is useful. You can see here they're using the same thing, replacing the so they're using that to replace there we go, to replace all the semicolons with spaces, but then they're going to say add this column tac t, and you can see if we do that, column tac t, and you can see you get a column for it. And this is even easier to read. So you can see you can kind of get very, very in depth with it, but all it's doing is making these columns, right? And the reason mine looks different than theirs is just because I have it so zoomed in, it's actually bleeding to the next line, but that's about it. So then you have awk. So awk is one that you're going to probably use quite a bit. It's usually my go-to, but you can use any of these. So you can see here, they're saying, hey, cat Etsy password, the same thing, replace all the things with spaces, and then they're going to say awk, right? Now, here they're saying print, and then they have this $1. That stands for the first field. So remember when we did cut, there was a delimiter field, and then it asks for what field we want to print. This is the same thing. We're saying print only the first field. Well, in this case, for the first field would be these names, right? Then they have the inf, and that is the last line, right? So you can see that would be this one over here. So let's say you only wanted, whatever. Well, the reason I like awk is because let's say I didn't want the last line. I wanted to know what users, and then I wanted to know their home directory. So I wanted this field, right? I would put print 1, then 2, 3, 4, 5, 6. So if we do it over here, we say we want awk, and then we'll say print, and we want the first field, and then we want the 6th field if I counted correctly. Maybe I did, maybe I didn't. And then, and it looks like I did count correctly, actually. Let's see. Yep. So now I have the users and their home directory, right? And if you look, you'll see the one, the hack the box one was in here. Hack the box, home, hack the box, right? So I was able to print, and by the way, this is the attack box, not the SSH, the box we were SSH into. I'm SSH into it here. So if you're wondering why the results might be different, that's why. So you can see the awk actually is really nice because it allows you to really kind of only display the fields you want, and allows you to then keep progressing, meaning let's say I only wanted these, but then I want to grep for something else, I can do that. So it's a way to really start filtering out your contents. Then you have sed, okay? Excuse me. So there's going to be come moments when we want to change specific names. So they want to change something. It's true. You're going to want to replace certain things. For one, you might want dummy data in there, especially if you're doing reporting. For two, you might want something that's very distinguished. Maybe you want to say, like maybe you're listing out all the IP addresses, and right before them, there's like something, I don't know, like it just says IPv4 or something, and you want to say IP address, right, for reporting. Easy. Well, what you can do, and you can see we're all the way up to where we were before. They said sed s/bin/htb/g, and if you look, that replaced all these bins with htb, hack the box, right? Well, you might be asking, what the heck does that even mean? Well, the S, which is right here, stands for the substitute command. So we're substituting /bin, and we're substituting it with /hack the box, right? And then the G stands for replacing all the matches. So what we're saying is, hey, substitute all this and replace it with hack the box. Perfect. Pretty simple. Now, these use cases are a little bit more, we'll get deeper into your career, because typically you're not reporting you might be sending out information, but you're not creating the reports typically. When you start creating reports and stuff, especially in Linux, this will come in super handy, because you're able to directly just change the output rather than put it into the file, go in with like Vim or something and replace all of it. You can just do it directly from the output, and I don't have to waste my time. Especially if you script it, right? Like if you have a script that you're like, okay, every pen test we have these reports, or every whatever we have these reports, like I can script, just replace this, right? Now, word count, we've already talked about word count a lot. Word count actually just counts the words. Now they keep adding this tag L. It just says count the lines, not the words. That's the main thing. Okay, so we're not going to do all these practices, but we are going to do the questions, because I think their questions, once again, don't make a ton of sense from it makes sense from a filtering perspective. It doesn't make sense because they didn't show you any of this stuff, but then they want you to do it, right? So not surprised. This box is kind of old and it has its problems. So how many services are listening on the target system on all interface? Now, here's the key. Not on localhost and IPv4 only. The reason I say that's the key is because you will run into some problems if you try to do all of it. So netstat's an easy one. So netstat, and then you just type in lnp4. All this is L stands for listen, N stands for numerical addresses, P stands for the process ID, which you don't have to have, but it's nice to know which program, and then 4 stands for IPv4 only. And you can see we get all these things, right? Okay, cool. How does that help us? Well, right now it really doesn't, right? So what we want to do is say, go ahead and grep it for listen. And you can see, okay, so we're starting to get somewhere because we just got the listen, right? Sorry, my back is killing me here. All right, so we're going to go ahead and say, hey, we want to listen to it. And let's see. So now we've got at least 1, 2, 3, 4, 5, right? But you notice if we go, how many services are listening on the target system, and if we actually go through here, sorry, I'm looking at my notes because, oh, that's why. I'm on the wrong box. I was like, this isn't right numbers. That's why. So netstat. So you got to do this on the SSH box. That's the main issue that I was running into, is I was doing it on the attack box, not the SSH box. So we'll say netstat, and you'll see we'll get a lot more results. There we go. And then I'm going to actually grep it for listening, right? Because I only care about the ports. If you look at the question, how many ports or how many are listening? Well, that's all I care about. Now you can see you really could stop here. The reason I say that is there's not enough that it's that big a deal. You can go 1, 2, 3, 4, 5, 6, 7, and that's good enough, right? Because it says here, not on localhost and IPv4 only. Well, localhost is 127.0.0.1, so just take those out, and you've got 7. So pretty quickly you can do that. Now, if you want to take it a step further, you can say grep, and we'll say tac-v to say not localhost, right? So 127.0.0.1. And right there, you can see we actually get 8 because we get this one, but it's still localhost. So we'll say 1, 2, 3, 4, 5, 6, 7. Again, could still do it. And then you can see we could take it even further if we wanted to. And you don't really have to at this point. You're already pretty much there, right? We could say, we want to say awk. And we want to actually print the field that we're looking for, which in this case is 1, 2, 3. It looks like the third field, right? So we could say print 3, right? Whoops. Oh, no, they're counting this as field, so we'll do 4. There we go. And now we've got just the hosts, right? Now we finally got this one, but what we could do to manipulate this if we really wanted to, right? I'm just saying if we wanted to, we could say, let's just get rid of this 127. There we go. We got rid of that 127, right? And then let's say we want to take it a step further. Now we can just say word count tac L, and there's your answer, 7. So with 7, you don't really need to filter that much. You could, I mean, I just went overkill, but I just want you guys to see that you can do it, and it's, it's possible. Now, the next one, this one says, determine what user the pro FTPD. This one, I don't really understand why they did this one, because for one, most people don't know at this point in Linux that PS is for processes and aux is shows all the processes. So use PS aux, and then just use grep pro FTPD, right? This is all you need. I don't know why they introduce stuff like this. Like, just have them open a file and then filter things. Like, that would be a much better way of doing this, rather than, I understand the real world use case of this, like, but the problem is you haven't shown them how to do this yet. So just know PS aux, that works great, and then grep pro FTPD. Now, here's where it gets complex if you don't know how this works, because it's not your fault. Like, they didn't show it, right? This is the username here. So that's why you can see hack the box student and then pro FTPD. Well, it gets confusing because pro FTPD is a username. It's also the service name. So you look at it and you're probably like, okay, that's the service. Okay. But that's the username as well. So just know that's the username. So just know that question I don't like either. Now, use the curl command from the pwn box, not the target. So this is where I have this, because you have to do it from the pwn box, not the target, which is fine. All right. And so first thing, we're going to build this out, right? So we're going to take our time. We're going to build it out, and we're going to make it make sense, right? So first thing is curl HTTPS. what was it? Inlane freight. I'll just copy this. So we'll say curl inlanefreight.com. We should get, so you can see right here, and this is a good use case. I like the way they did this. So you can see we have all this. This is the source code of the website, right? But what they're asking us to do is tell them how many unique paths do they actually have. Well, the nice thing is we can actually say curl, right? grep, because we know that it's going to be inlanefreight.com, because they told us basically, look, this is what it's going to look like, inlanefreight.com/directory. So if you look through here at the source code, and this is the best way to do it, is if you know the file, it's a lot easier to manipulate. Look for inlane freight, excuse me. And if I can find an inlane freight, I could just grep for it, but there you go. Inlanefreight.com, WP. You notice that they're all going to be slightly different, so you don't want to use the whole address necessarily, but I'm just using inlane, right? So now we say inlane, and you can see, okay, now we're starting to get somewhere. We've got it down to a lot more results, right? Well, now what I want to do is I actually want to find these spaces, because there's little spaces in here that you can't see, like right here at the end and stuff like that, and I'm going to make those new lines. Remember I told you that this would come in handy later, so we're going to use tr, and we're going to replace any spaces with a new line. And the reason we're going to do this is simple. I want it to be easily displayed for me and see where's the gap, or where's the separations, right? So we do that, and okay, you can see now it's breaking it down for us, because the lines that are overlapping, like these ones, don't run into the next one. So okay, so now we've got it. At least we can start seeing. All right, perfect. And typical website, you're gonna have href, which is a reference. So that's kind of what we're gonna focus on here. But first thing I'm gonna do is I'm going to actually say, hey, I want to sort this to unique lines, right? Because I don't want, they want just the total. They don't want us to have multiples, right? So we're gonna sort it to unique lines. You didn't really see a change here if you weren't paying attention, but really you can do this at the end too. I just wanted to sort it so that we only have the unique stuff, right? Now what we're going to do is we're going to actually take it and we're going to say grep, right? And we're going to grep for source and href, which we know is a reference if you know HTTP. And okay, now we're looking pretty good, because now we have source and reference, right? So right off the bat, could I count these? Probably. But if I can just do word count tac L, there you get 37. So that seems complex, but it's really not when you break it down. What you do is you just look at how the file is displayed, and you say, hey, we curled it. We wanted to grep for inlane because we knew it was inlanefreight.com/something, right? Then I just put it all on a new line so I can actually work with it, because otherwise it wasn't going to sort properly and stuff, because technically they're kind of on the same lines. And really what I cared about was counting those lines at the end. So then really right here with grep inlane, you have what you need. It's just not displayed very well. So then here I put on a new line, right? And then I just got rid of, I just looked for the sources and the references, because that's how a website, or in this case, this website actually talks to, that's how it actually references these websites, so, or these pages. So that's why I did it this way. All right. Now, regular expression. We're not going to get too crazy into the regular expression for a reason. One, there is regular expression generators out there. Two, regular expression could be an entire box on its own. It is really, really, really useful to know, and really important that you at least are dangerous in it. You don't have to be an expert, but be dangerous in it, right? So at its core, a regular expression is a sequence of characters and symbols that together form a search pattern, right? They often involve special symbols called meta characters, which define the structure. So here they're talking about, you have, and that's, by the way, that's what this E was in grep, if you didn't see it. That tac capital E is, it's saying, hey, I'm going to use a regular expression basically, or I'm going to use an expression. and then I put in here, I want to search for 2 things. That's pretty much what it was. So, okay, now, all right, so we have the brackets, right? Just the brackets, the round brackets. Within the brackets, you can define further patterns that should be processed together. So you can see here, you might not noticed it, but the brackets say this is going to be like a pattern inside that I need you to process the whole thing. And we put this here, the pipe, that's the OR operator. So when we said source ref with the pipe in the middle, it was source or ref, right? Not and. Source. So the reason you do or and, the big difference is it can be either or, and means it has to be both, right? So then you have these square brackets. This is what you're probably used to seeing if you're used to seeing regex. Square brackets are used to define character classes. So usually when you're using square brackets, it means like, I'm going to say like this, A to Z, right? That means anything A through Z, right? But in this case, it's all lowercase. 1 through 10, these are to define quantifiers, numbers. Inside the brackets, you can specify a number or range, right? And that's really useful for, if I want to range, I will only want to find IPs in this range or whatever, right? Really nice, because you can do something like this. And I'm not doing the full regex, but I'm just showing you. If we just say clear, we could do something like 192.168.1 or .2, whatever, dot, and then not every, I know that like nmap will take like 1 through whatever, but not everyone will. So what you could do is you could say, I want range 100 through 225. I just made up a range, right? And that would be a regex expression that if you had it read, it would do that range for you. So anything that can take regex, you can get really specific with the patterns. Now, you can see here they have the OR operator, which we talked about. And then this is the AND operator, and this is the period asterisk. Now, the OR and the AND are important to know the difference, because I see people sometimes mess those up, and I've been guilty of it myself in the sense of I'll be like, okay, I want this and this. But really what I'm meaning is I want this or this, right? So make sure you know the difference. Like this one, it'll search for my or false. And I don't see, there's my, but it also has false, so that's not it. The AND operator means it needs my and false. So that's why you see the MySQL and false, and it gets rid of the rest because only one of them shows my and false, which is this one. Okay, then here you can see here they're searching for the expression my, okay, and they found that, great. And then they're searching for false, so I guess they're just showing a different way to do it. But what they're saying is, okay, here you'd have to use grep twice, here you could do it once. That's true. That's just saving you a little bit of time. Now, the reason I'm not going to dive into this is too much is because, again, they don't show you all of this stuff, but you can go through and do the practices. I recommend doing like a regex box. I know TryHackMe has one. I don't know if Hackbox has one for sure, but I recommend doing a regex box before just assuming based on this, because they just walk through it really quickly. I'm not going to dive into it real deep on here because I could do an entire video on regex. If you want me to do a video on regex, tell me. I'll do a video on regex. Happy to do it. But they don't really give you any questions here, so it's not even worth breaking down. They showed you 4 regex operators, and that's it. Okay, now permission management. So in Linux, permissions are keys, right? In every computing, permissions are keys. You need good permission sets, or else it all goes to hell, because if I have incorrect permissions, I can do more than I'm supposed to. Super easy to take over a box, right? Pretty self-explanatory. Now, we talked about LS, and they use AL, I use LA. It doesn't really matter, but it's the same operators. But all in the list, right? So it's listing our permissions, and we've talked about this before, but we displayed this permission set right here. We just briefly mentioned it before, but we're going to talk about that and why it matters. So a couple of things. First thing, let's see if they break it down the right way. Okay, so they do break it down right here. So first thing I'm going to break down is I'm going to skip the read, write, execute for now and talk about this, and then we'll go back to it. So the first thing is the very first one right here, that very first little tac, right? That's the file type. If it's a tac, it's a file. If it's a D, directory, right? And then L stands for link. In Linux, there's a lot of links. Think of them as a shortcut, right? But it's a link to a file. Then you have this one. This is the owner. It's really important you understand it's the owner, right? Because if I create the file, I'm the owner, right? Not root or whoever. I'm the owner. So that is read, write, execute. We'll talk about them. Then you have this one here, the next group, and this is the permission of the group. And then this last one is permission of others, so anybody else. Now, it's really important you understand this piece because it can get, if those are all full, it looks hard to understand fully. So we'll cover that here. Now, then this right here, this 1 is the number of links that the file itself has. This is the user and the group. So this is who created the document, basically, what group they're in. File size, then the date, right? And then this is the actual password or the actual file. So I'm going to show you guys when I say it can get really busy, what I mean. So we'll say touch example. So now touch command's not okay. Nano example, and we'll just say test. And so now we have in there, you see that example. Now, if I change permissions to 777 and I say example, now if I ls tac LA, and we'll do this to make it even easier, we'll grep it for example, so you guys don't have to see it. You can see this gets pretty difficult to read pretty quick, right? Because you're like, okay, there's a lot of RWXs, but so think of it just in threes, right? Read, write, execute for the owner, which is me. Read, write, execute for the God bless it, the group, right? And by the way, the group here in this case, which you'll see, is me, but you can change the group. And then read, write, execute for everybody else. Now, it's really important that you just break it into threes because I'll show you. If I do like, let's do 764 just so you see it. And you can see here these dashes. Those are placeholders, meaning they don't have those permissions, but they're placeholders. So still break it into threes, right? This means it's a file. This means read, write, execute for just the owner. This means read and write, but the execute actually has a tac, meaning it's a placeholder, doesn't have that permission. And then for the group, and then everybody else just has read access only. So if you can break it into those threes, it's pretty easy, but because there's only 3 permissions, but make sure you break it into those threes so you understand. Now to change permissions, there's multiple different ways, right? So we can modify the permissions using change mod, which is what I just did. And they have you do this, right? You can do user, G for group, or others. And then they use the plus or the minus. So plus adds permission, minus takes permission away, right? One thing I will say, so let's assume we have a file called shell. We want to change permissions. So they list it, read, write, execute, and then they have execute, execute. But then they use change mod, A plus R. Well, A would be others, or all users, excuse me, right? And then they want to add, so plus read access to everyone. Well, now when you go in here, these 2 users have read access as well, right? So pretty easy, pretty self-explanatory, right? But you can see we can also set the permission for all others to read only using the octal value. So this is the way you saw me do it. I don't care if you do it this way. This is just how I've always done it. I learned years ago. I don't really care how you do it. But some people get confused by the numbers. If you need to use the UGOA and the plus minus, go for it, right? Read, write, execute. There's symbols, very easy. Now the binary notation, this is why it is this way. But just know this. And it's really, the way they have this broken down is really not simplistic. They don't, Hack the Box is not known for their ease of teaching, right? They sometimes make things the most difficult. just know it is this, right? So you have octal value for read, write, execute is 7. I have no idea why they're doing this. This is really frustrating, actually. Do it this way, okay? Read access is a number 4, right? I understand they have the binary notation there, but I don't really understand whatever. So read access is 4, okay? Just remember that, 4, right? Write access is 2. Execute access is 1. That's all you need to know. You can do the math yourself. If you want read and execute, that's 5, right? If you want read and write, that's 6. If you want read, write, execute, that's 7. It's really easy, right? So I can say change mod 777 means change mod, add read, write, execute on all 3 groups, the owner, group, and other users, right? It's that simple. Just know the 421. I have no problem with this is all true. I just don't know why they added 421 at the top of all of these and didn't really explain it. They didn't really give you any details here. Just know 4, read, 2, write, 1, execute, and you can add up the math yourself. Again, most people don't. I shouldn't say most people. I see a lot of new people use the actual values up here, like U, G, O, and then the plus minus RWX. Cool. No one cares. Use whatever you want, whatever makes it easier for you. Now, SUID and SGID. So this is set user ID and set group ID. So these bits function like temporary access. What they allow you to do is when you run an application. So for instance, think of like any application on your Windows machine. When you run it and it says, oh, you can't run this unless you have admin access, and asks you if you want to run admin access, right? If you have admin access, think of it that way, right? It's just saying this application has to run as admin, and that's depending on if someone set it up that way, and it will run as whatever user you want, right? So usually you need to run it as root or admin or something like that. And so you use this SUID or SGID bit, and you say every time that a user runs this application will run as admin. Okay, very, very big on exploitation, because when you're running anything as admin or root in this case, it's usually, if it can have any other effect, it'll happen. So just know that. But there are times that you may have to run something as admin to get the results you want, right? Like if you have to run an application and you're, help desk user, right? But that application requires you to do your job and it needs root access, but they're not going to give you root access. The best alternative is to put a SUID bit on there so that actually runs as admin or root, and you don't have to have root access or log in as root every single time, because that's more dangerous. Now, sticky bits are like locks on files within a shared space. So you can see here they have them right there. And you can see when set on a directory, the sticky bit adds an extra layer of security, right? Ensuring that only certain individuals can modify or delete them. So it's kind of like putting a lock on it is a good analogy there. So imagine a communal workspace where you can enter and use the same tools, but each person has their own drawer, okay? The sticky bit acts like a lock on the drawer. In a shared directory, this means that only the file owner, the directory owner, or the root user can delete or rename the system. You see this a lot with like backup files, right? If they do that, you can take the backups all day long. You can take backups, you can put them in there, whatever. You can't touch the ones that are in there, because once a backup's in there, it shouldn't be touched, right? That's kind of what they're saying. All right, that's just the end of that. Oh, there's no questions on that. Okay, so that is pretty much it, guys. The sticky bit, that kind of came to a halt real fast. I thought there was more to it. So you can see that both the directories here have the sticky bit set, right? However, the reports folder has an uppercase T and the scripts folder has lowercase t. Okay, if the sticky bit is capitalized, that means that all other users do not have execute permissions. So that's everything in that directory, right? Therefore, cannot see the contents of the folder nor run anything from it. The lowercase sticky bit where the execute permissions have been set. Okay, perfect. So they can execute in that one. So here you can see they can execute scripts. They cannot execute or read reports. Perfect. Awesome. Extra lockdown on it. All right, guys. So that's going to do it for this video. But we're going to, so we covered all of this. The next video, we're going to cover the system management, Linux networking, Linux hardening, and et cetera, et cetera. And we're going to dive in. So hopefully this helps you guys. I know this is a long video. I know I've done this box before, but it has been updated a lot. I get questions in the old video a lot that say like, my questions don't match up or whatever. I understand. So I'm trying to get you guys the newest one, and we'll try to, if it changes again a year later, I'll try to get another one. So hopefully this helps, guys. Hopefully you guys have a great day, and make sure you like and subscribe. Thanks. Yo, what's going on, guys? Welcome back. Today I'm doing Linux Fundamentals Part 2, and you can see I'm going to be doing system management today, and then I will do Linux networking, hardening, and the rest at the end. That'll be my last video on this. And the reason I'm breaking it up is, one, I'm still pretty sick, so I don't want to talk for that long, and two, I just think it makes more sense to have it kind of the meat and potatoes in 1 and 2. So we're going to talk about user management. So in Windows, you usually have Active Directory, domain controller, something like that. In Linux, it's a lot of local and groups. When I say local, I'm talking about on the machine. Now, there are some more complex systems, and you can actually integrate Linux in some capacities with AD, but we're not going to go into deep weeds of that. So before we dive too deep, guys, please hit that like button, hit that sub button. We just hit 25,000 subs, and I am going to be doing a special 25,000 sub video. So I really, really appreciate that. But I want to make sure we keep this train rolling. If you guys like these type of videos, check out the Patreon. The Patreon's in the description. In the Patreon, you get all kinds of exclusive content that isn't seen on my YouTube. Plus, you get one-on-ones and resume reviews, mock interviews, all that stuff. So let's go ahead and get into it. So you notice they go ahead and try and open the Etsy shadow file. The Etsy shadow file is actually like it's got your usernames and passwords. So it's basically everything, right? It stores them in hash values. So that means I can crack the hash, I can pass the hash, I can do all kinds of attacks, right? But you notice when they do this with a regular user, we get this Etsy shadow file permission denied. So what they're showing is if you run it as root, which is using sudo, it runs it as root. And if you run as root, you have access. So you can now see that they get it. So here's a list that will help us better understand and deal with user management. So you have your sudo. This executes commands as a different user. One thing I see people all the time actually get a little bit confused on is they think sudo only runs as root. They say like, oh, this person has sudo or access, meaning they actually can do run things as root. But if you look at their permissions, if you list them, a lot of times the permissions will say they can run them as another user. Sudo actually can run as any user if you have permissions. SU is switch user. It allows you to, if you have the correct permissions and everything, right, and user credentials, you can actually switch users, so you can actually log in a shell as a different user if you need to. That's why when you do sudo su, it switches to root. Now, user add, this creates a new user. User delete, deletes a user. Modifies user mod, modifies user count. Add group, adds a group, right? Delete group, deletes a group. And then PASSWD is changes user's password. For the most part, I will say Linux users and permissions and stuff is pretty simplistic. It's intentionally that way. It can get very complex if you're using like a mainly Linux operating system as your entire enterprise. This is why most enterprises run on Windows, because of the usability of the groups and permissions. It would be very, very difficult to stand up a very large enterprise on just Linux. When I say difficult, doesn't mean impossible, doesn't mean it can't be done. It would mean that you need a very skilled Linux people to do that. All right, so which option would need to be set to create a home directory? User add. If you type in the man page for user add command, you get this tac im. So, or if we just say help. So like if we just go right here, and I know this is kind of small. So if I say man, user add, here's the man page, and you just scroll through and you find the tac im. And I may just pass it, so let me know. There it is. Create a user's home directory. There you go. Which option needs to be set to lock a user account using the user mod command? Well, all we got to do is say same thing, but user mod. and we're looking to see which option needs to be set to lock a user's account. And if it's in alphabetical order, so you just keep scrolling. There it is. Lock, right? Tac lock. Now, I don't know if the tac capital L will work there. It might. Which command needs to be set to execute a command on a different user using the SU command? So you just go in here and you say SU, and we're trying to see which one allows us to run to run another command. And it's the very first one. Pass command to the shell. So there you go. That's how I got those users. Let's keep it moving. Package management. This is actually something that many people get, I don't want to say confused on. Even myself, being in Linux forever, I get not confused, but I'll get mistaken on to like which package manager I'm using, or like if I go to a new place, or if I'm doing a some sort of assessment or something like that, and I'm looking at their Linux, I have to remind myself, refresh myself, or look up what package manager they're using, or ask them. So you can see package manager, whether you're working as a sysad, maintaining your own Linux, blah, blah, blah. It's crucial to have a firm grasp on available Linux package managers. That's the key here, is know what package managers are available. You don't have to know which one they're using, because you can ask them for one, you can figure it out for two, or you can use a different one. So you have your dpkg dpackage. This dpkg is a tool to install, build, remove, and manage Debian packages. So dpkg, Debian packages. The primary, more user-friendly front end for dpkg is aptitude, and we're going to talk about that. Then apt. This is the one you see a lot. Apt provides high-level command interface. This is where you usually see like sudo apt get, that type of thing. You'll see those a lot. Then you have your aptitude. It's an alternative to apt and is high-level interface to the package manager. Then you have snap. Install, configure, refresh, and remove snap packages. Snap enables the secure distribution of latest apps and utilities for cloud servers and Internet of Things. So you can see slightly different use case there. Gem, front end for Ruby gems. Pip for Python, and Git, which is for GitHub, excuse me. So you can use things like GitHub and download repos and stuff like that. That's what Git's for. And you can upload repos and all kinds of stuff. So you have your APT, which is your apt, your advanced package manager. So this is basically what, long story short, how does this all break down? You have a package manager. That package manager has a set of repositories where certain packages or applications are stored, right? It knows which ones are secure, safe, and etc., right? And they're published to that repository. So when I go download something, it's kind of like going to the Microsoft Store. I don't know if anyone that does this, but if you go to the Microsoft Store and buy something, you download it from there. You know it's safe. You know it's fine. Whatever. If you can use any repository you want, but understand if you change from the default repositories, there's no confirmation that those are good repos, and there's a lot of things that can happen. Even some of the ones in here probably aren't the best. So you can see here, if they're going to cat etsy apt sources.list.d parent list, and they're looking at all these different repositories, and you can see they have this one for Debian, this one for source Debian, etc. These are all the different packages that they're actually able to find. So what it'll do, you ask for something, it goes to these sites, it looks for it. If it finds it, downloads it. There you go. Pretty simple. Now you can see here they cache it and it searches for it. So it's gonna say, hey, I want to see if Impacket exists. Well, it'll tell you if Impacket is in those repositories or not. If not, you may have to add a repository or go download it some other way, right? That's where things like GitHub come in and stuff like that. Now you can say the cache, you can say show Impacket scripts, right? You can see that one right here. They want information on it. There's all the information. And then they can say things like list all the installed ones. So this is all the installed packages on your machine. Then here, this is the easy way to install something. Sudo apt install Impacket scripts tac y. Now, if you watch my videos, I don't really typically use the tac y. Just call me old-fashioned. It's really no reason besides the fact that I make a lot of mistakes. And so tac y means instead of Linux asking you, are you sure you want to install this? And you say yes, it just says yes. I don't do that because I make mistakes a lot, and I like to double-check myself. That's really the only reason. Now, GitHub, again, we talked about this. You can go to GitHub, any GitHub page you want. In this case, it looks like this one, this niching we're going to use. You can see here they did a make directory first. So they're going to make the directory called nishang, and then they're going to say and, then they're going to get clone, which means clone the directory. And they're doing that basically, and we're going to go ahead and do that because it says to do that. So we'll go ahead and do that. And it says we're going to use it later on. I actually don't know if we do, but whatever. Okay, now dpkg Debian package. We can also download programs here, and you can see here they're actually downloading things here. And again, they're just using wget. They're saying you can just directly reach out to those if you want to. If you know the exact URL, feel free to reach out. Here they don't know the full. You can see they don't have the full URL. Excuse me, but they knew it was called strace ... and they do that, and it actually pulls it the same exact way. So the difference is, one, you're directly calling it out. The other one, it's going to search the repo until it finds it. And then they say, hey, strace tac h, because now it's installed. That's really all they're showing you. Really, all you need to know is, how do I install stuff? I tell people this all the time. You don't need to memorize this stuff, mainly because if you don't know, you can Google it. You can look it up. It's super easy. You do this 5, 6, 7 times, and you're going to remember how to do it, right? Most people know it's sudo apt-get, right? And then you can get whatever. And then you click install, type install, and you're good to go. Now, this one, the one that I see people usually not as familiar with is the git clone, but nowadays, almost everybody uses GitHub, so most of you guys are probably familiar with it in some capacity. Okay, now, services, also known as daemons, are fundamental components of Linux. So user installed services. So these are services added by the user, meaning they weren't just default. They weren't sitting there. The user added them, right? And other background processes provide specific features or capabilities. So what we're going to talk about is daemons here, which are services, things running on the machine, things that are happening. You can see here they're using system control to start SSH. Now, what this does is the system control SSH means, hey, start it up SSH, so now you can remote into my machine, or I can remote into your machine, etc. Right? That's what SSH is, secure shell. It gives me a secure shell in your box. Now, then you do status. You can do this with any service. It doesn't have to be SSH. And you do status, and you can see it's telling you, hey, the service is running, blah, 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 everything's good. Now, when you do enable tells it to start on startup, meaning, so the difference is start means start it right now. Enable means let it start every time I start the machine. This is really important because if you have a service that like SSH where you want to remote desktop every single time, well, you can't unless you do this, right? Because it's not going to start up unless you manually start it. Then you can see they do processes here. That's what PS stands for. Excuse me. And they actually grep, meaning they're going to search for SSH. They find that, and there you go. There's your process running. Okay. They can also use system control to same thing to search. So you can use system control to start the service and everything. And then you can say list units type service, and you can look at all the services, and the one that you just started will be in there. You can also do the grep afterwards also. So it's quite possible that the services do not start due to an error. So this is probably one of the most common things you're going to run into if you're ever a Linux admin or just a system administrator in any capacity is, hey, we patched your servers, blah, blah. Services didn't come up. Services have to start in a very particular order when you get to complex applications. And a lot of times if one hangs or slows down or whatever, it stops that next one and the next one and the next one, and it starts a chain reaction. And when this happens, you have to see those errors. So use journal control, tac-u, ssh.service, and then you can see it gives you the logs for it. There's other ways to do this. You can, any way you want to view the logs is up to you. But if you're having a service that breaks, you typically need to do a couple of things. One, kill it, right? So you can see kill tac-l gives you a list of all these different things that you can do. Well, the ones that you really need to focus on are things like 1, 2, 3, 9, 15, 19, 20. So you have sig hup. This is sent to a process when the terminal that controls it is closed. So this is, if you close the terminal, this is automatically sent out. This is how you close things. Like if you've ever opened like Wireshark, but you type it into the terminal and you type in Wireshark, it'll open. And I can show you what I mean right here real quick. I don't know if Wireshark's on this, but let's try and see. So if we say Wireshark, so you notice it's running Wireshark, but if I close this terminal, close terminal, Wireshark closes as well. So the reason it does that is because right here, that sig hup was sent, that exit code was sent, right? So now sig int, this is signal interrupt. Most of you guys are probably most familiar with this one. When you hit Control C, it cancels anything. It says, hey, stop everything you're doing to interrupt the process. Sig quit, this is Control D. When a user pushes this, it says, hey, quit, right? Sig kill, this is the one that like, hey, this is, the process is hanging. There's nothing we can do. We have to get it to stop. You do this, sig kill, and it will immediately kill it. Now, keep in mind, you can do the numbers as well. So you notice it says kill 9. They're saying, hey, kill 9. You need to kill that process in whatever process ID, and it will actually kill it directly. You don't have to like, it doesn't do any cleanup operations. It might break something. You got to turn it down. Now, sig term, termination, sig stop, stop the program, and then sig stop here, sig T stop, excuse me, is when you press Control Z. So there's a lot of times you'll see certain things like Vim, and I don't remember all of them, but some of the word processors, they actually have you press Control Z to to close. I think more or less uses Control Z, maybe just Q. I can't remember off the top of my head, but Control Z is another one that you'll see quite a bit. So if you want to background a process, that's where Control Z comes from. Okay. Now you notice what it does. It suspends it. What that means is whatever's running, it's going to say stop, wait in the background. If any of you have ever used Metasploit or MSF console, a lot of you are probably familiar with this because you can background sessions in terminals, and then you can come back to them, background and foreground them. That's what Linux allows you to do. So like if I'm, in this case, you see they're using ping and they just did 10. Well, what they're saying is, hey, I pinged it, and then I'm going to Control Z, I'm going to background it, and it's going to stop. It's not going to run anymore. And then when I foreground it, it'll keep going. So you can see here, they're looking at the jobs. The jobs here, it stopped. Vim temp file stopped. And then you can see the Control Z shortcut suspends the process. And then here, they background it. You can do the same thing if you have a process that's running. And then you can say, if you do the and here, you can see where am I at here? There we go. That's what I was looking for. So if you want to foreground the process, you can just go foreground 1. So whatever session it is. So if you go foreground, see how it has this little number here? I don't know if you guys can see that. Let me see if I can make it a little bit bigger for you guys. There we go. Foreground, and they have this little 1. So that's kind of your session number, if you will. And you can foreground that. And when you foreground 1, you can see it continues. So that's a way to stop a process, suspend it. Maybe you were doing something and you're like, oh, hold on, I got to do something else first. You can stop it, and then boom, okay, you're good now. You've got it. So now here is a couple of the operators you're going to need for multiple commands. So the big one, semicolon, this says, hey, run this, stop, now run this, stop, now run this. Double ampersand says run this and run this. And then the pipe says run this, take the output, and put it into the next command. So we'll show examples of that. So here, echo 1, 2, 3. Every time they do that, it just goes 1, 2, 3. Here, they do echo 1, and then they say ls. There is no file there, and then echo, and you can see it does it in those orders. But if you do echo 1 and ls, missing file, and echo 3, it's never going to get to this because it's going to say, well, I can't execute this, so there's no and because there's nothing, this one didn't complete. So you can see it says 1, then it says no such file or directory, and it never gets to this because it's saying do this and do this, but it never did that second step. Okay. Use the system control command to list all units of services and submit the unit name with the description load app armor. Okay, so let's say system control, and we're looking for the one with the description of something app armor. All right, so what we're going to do is we are going to say, we're going to go back up here, and we're going to say, let's just do, there we go, system control, list units, type service. I'm assuming it's a service considering that's what we have been working with. Okay, and we're looking for load app armor. So I'm going to show you guys how to do this. You can do that, and then you can say grep, and we'll say load. If it is exactly that, app armor, and we'll just leave it like that. And you can see the only one there is app armor.service. So there we go. There we go. So, and then it's just snapped d.armor.service, which is this right here. Oops. There you go. And I don't know if just the app armor.service will work because this was already plugged in from the last time I did this box. So I don't know if that'll work. Okay, now task scheduling. Most of you are familiar with task scheduling. Give me one sec, guys. All right, so most of us are familiar with like what scheduling a task is. In Windows, we have Task Scheduler. In excuse me, in Linux, we have a couple of options. So we have My Timer, and then we have cron jobs. Most of you guys have probably heard of cron jobs, especially with like privilege escalation and stuff like that in Hack the Box. And in general, but My Timer is one that even frankly I haven't used, mainly because I never needed it, but it doesn't mean that it's not good to know, because if someone used this, then you want to be able to check that as well if you're a penetration tester and ensure that they didn't schedule it this way. So systemd is a service used in Linux. We already talked about this. Set up processes. So what we need to do in order to use this My Timer, right, is we need to create a timer. That's our first step. Create a service, and then activate the timer. So you can see there, you're going to say sudo make directory, and it's in the etc systemd system mytimer.timer.d. And then they're going to actually edit this mytimer.timer. And in that, they have the unit description. So in this case, they're just calling it My Timer. They have the actual timer. So on boot, 3 minutes, and then every hour after that. Okay. Now, one thing I will say that is really nice about My Timer is, if you guys have ever ran into this, there's times where you run into, if you have too many things starting up on startup and they can conflict with each other, you can set a little delay, and I like that. And then you can actually say, start this up, and then start this up, then start. You can kind of schedule that order if it's ever getting out of whack or if things are conflicting with each other. Now, install, you want to install timers.target. And then you can see here, we're going to say vim. Okay, so now we're going to actually edit the service, which is mytimer.service. And you can see, again, we have unit, we have our description, which is my service. We have our execute on start, which is, in this case, full path to the script that you're going to run. So whatever script you're running. And then you want to say install wanted by multi-user target. So what the multi-user target stands for here is when starting on normal multi-user mode, meaning when a normal user logs in, multiple users, whoever starts this up, it's going to run. Reload systemd. So in this case, they're not restarting the box. That's why they are doing this. If you were to just restart the machine, it would do the same thing. Don't do that on your attack box or whatever they call it in Hack the Box, because if you restart it, it starts up a fresh instance every time. That's why they're having you go through this. But you would reload it, restart it, and then enable. You notice they said start the timer, but then also enable it, meaning start on startup. So that's really important that you enable it. If you don't enable it, then what ends up happening? Well, nothing, because you have to manually start it. Cron jobs. Now, cron jobs is a file that, cron tab is what they call it, but it's a file that is in your system. All right, so then we get to the cron jobs, which is basically another tool to schedule processes. This is one you're probably more familiar with if you've ever used Linux before, but this one, some people find more difficult to understand. I actually find easier, but that's because I'm used to it. So for me, it's just comes more natural. So you can see, excuse me guys, sorry, I'm pretty sick. So you guys can see that the system basically comes, or the file itself looks like this. You've got whatever here, they just commented out whatever it is, they called it system update. And it breaks it down from minutes, hours, days, months, and then days of the week. So in this case, 0 minutes, and then you can see it's going to run every 6 hours. Excuse me. So what that basically means is, or every, I'm sorry, on the 6th hour, excuse me.
And then these, all the asterisks are just wild carding them out, saying nothing. This is the way to, the hard part is to look at it this way, where you got 0 minutes, 0 hours, and then 1, which would be the days of the month. So that would run on the first of every month. Then you have here, you've got 0 for the minutes, 0 for the hours. So that's midnight basically, because there's no hours, no minutes. And then you got here, it's going to run on days of the week, 0, which is Sunday. So again, once you figure out the structure, it's really easy. The nice thing is nowadays with things like AI, you could simply say, hey, here's what I'm trying to do, and it will give you the exact output that you want. And then you're just telling it which script you want to run. In this case, backup script, cleanup script, run scripts, and update software. So really, really simple. I think cron jobs is a little easier. You don't have to do all the extra steps, but that's just me. What type of service? What is the type of service of the deconf service? That is a full mouth puzzle. I don't even know what that was. Let me reset this and see if I can get it to. All right, we've got our system up here. We're going to go ahead and try to identify. Oops. Why is it? Oh, I'm hitting the wrong button. That's why. I was hitting caps lock. All right, we're going to try to find what is the type of service of the deconf dot service, which is an interesting way to even word that. I don't even know that sentence makes sense. So the big thing I'm going to do here is just try and find it first. I don't really know where this might be, but I'm just going to say deconf dot service, since everything in here is a file. And then we'll just say, we'll just leave it at that and see what we get. Then to dev null, just see what we get out of that. Okay, didn't find anything there, so that's good. I don't know how it didn't even run, but that's all right. Let me try and switch this baby out. There we go. I just put that in the wrong spot. Okay, so there we go. We've got user live. So let's try and nano, or we can just cat it probably. I don't know how big this file is. We'll see how big this file. Okay, it's not very big. Okay, and there's the type right there, dbus. And there you go. So this one, I don't really, this is once again, you guys hear me talk about hack the box quite a bit, but this one is like, once again, it doesn't really make any sense to me. Like, how does this correlate with all of this? Your guess is as good as mine as to why they had you search for this configuration file in order to determine what type of service it is. But yeah, that's the easiest way I know how to do it. There's probably easier ways. There's probably a way with some of these commands that if you really dig into the help commands and stuff, there's probably an easier way, but that's the easiest way for me, is just find it and then open it. All right, so we're going to talk about network services. So the big thing here with network services is how do you connect in? Most of what they're talking about here, if you look, is kind of like remote administration and that type of thing. So SSH is secure shell. We already talked about this. It's a way to basically remote into the machine and have a secure shell. It's an encrypted channel where you can actually talk on there. You can see here they're showing you that you can actually install it, and you notice they're saying open SSH server versus the SSH client. The reason you do that is because that means I can connect to it. The client itself just lets you connect to other stuff. But then you can see they do the status, and you can see, hey, there you go, it's enabled. Perfect. When you log in, you're just going to say SSH, and in this case, they're using CryoLite. And they're saying CryoLite at 10.129, da, da, da. Let me see if there's an actual server I need to start up for this one. I don't see one. There's not even an answer or a question, so perfect. Okay, so when you're logging in, you just say SSH user at IP. Pretty simple, pretty easy. They don't show, oh, here you go. Yes, they do. It says, are you sure you want to continue connecting? You say yes. Once you do that one time, you should never get that again. So that's good. It's just saying that, hey, this is maybe not who you think it is, type of thing. Network file system. This is a network protocol, allows us to store and manage files on a remote system as if they were on our local system. So your network share is similar to what you guys are familiar with. You can see here they're going to install it once again. they're installing the server piece of it here, right? Versus the client, which the client is the piece that's just going to connect to it. Excuse me. We can configure the NFS via the configuration etc exports. This file specifies which directories should be shared and access rights for users and systems. So if I want to share these files, I can specify in here which files are going to be shared, who has permissions, all that stuff. Then here, permissions similar to what you see normally, read write. RO gives user systems and read-only access. No root prevents the root user on the client from being restricted to the rights of a normal user. Restricts the rights of the root user on the client, etc., etc. Synchronizes the transfer of the data to ensure that changes are only transferred after they have been saved on the file system. Transfers data asynchronously, which makes the file transfer faster, but may cause inconsistencies. So this is a big deal if you are working in high volume data. You may really need to think about what you're going to do here, because you might not want those inconsistencies, right? So you can see here, they're actually making a directory to share here. In this case, NFS sharing. They're echoing home, cryolite, NFS sharing. That's the share. And then they're saying hostname, blah, blah. They're putting that into the etc exports. So what they're saying is, hey, add this share, which is NFS sharing, to the etc exports, the host name, and then we want all these permissions. And then you can see they're going to actually cat that, and they're going to look for this. Okay, great. And that's what they get. All right, now what they're saying is, tell me everything that's not commented out, and then the only line there is the one they've got, which they probably didn't even have to grep for. They probably could have just catted it. But all right. Now the key here is they have to mount it. Once you have it created, that's fine, but it has to be mounted. And so they're going to mount it here. They're going to say target NFS. So this is on a different machine. They're going to mount it as if it's sitting on their machine. So they're saying, hey, let's make a directory to mount to, right? Target NFS is the one they're talking about. And you notice they put the IP first, then home, John, dev, scripts, blah, blah, whatever. And then they're going to say target NFS. So there you go. And then when they look at it, you can see it actually looks like it's just sitting on the network. It looks like it's just a regular directory. All right, now web server. Most of you know how to use a web server. As far as like accessing one, most of you have probably accessed a website, and that's what a web server is, right? So in this case, they're talking about actually running a website. So they're saying sudo apt install. We talked about sudo apt as a way to install things before. We're going to sudo apt install. In this case, they're going to use Apache 2. The tag Y just stands for yes. Like, it's going to ask you if you want to do it. You're going to say yes. And then you go down, and you can see this is the Apache configuration. But when they actually stand it up, you can stand it up using whatever. But you can see here, they're actually going to use, they're talking about all the different permissions and all that stuff as far as var www html. That's usually your home directory, meaning home directory for the website. So what that means is typically whatever's in this var www html, that's going to be what's on the website, typically. I say typically because you can store it somewhere else if you direct it, but just know that. And then they're saying here, now if you want to use Apache, that can stand up a good web server, that's fine. Then you can use Python. So this is actually the most simple one I use. I use Python Simple Server probably almost every day, just to transfer files. It's super easy. So you can say sudo apt install Python tac y. Most places, or most Debian boxes probably have Python on it. So then you just type in Python 3 tac im http.server, and whatever directory you're in, if you do it this way, whatever directory you're in, it just hosts that directory on the website. So that means you can go to the website. I could go to 127.0.0.1 or localhost, and there's all the files that are in that directory. So here, they're actually specifying a directory. They're saying, hey, I want to do this directory here. So the reason this is so useful is, like, if you have a target machine and you can run a command on it, you can actually run a command like this and start pulling files down, or vice versa. If I want to get a file over, I can host this on my machine, and I can just do something like curl or wget, and I can just grab them. I don't have to go stand a whole server up and everything. And then here you can see they do the Python 3 tac im HTTP server, but they put 443 at the end. That's specifying the port. Now, you might want to do this, especially if you're getting an error, because sometimes you'll get an error like the port's already in use, like port 80 or something. It could be because your machine's already connected to something on the internet. and you have to change that port. You can see here the default port is 8000, but you can use whatever. VPN is exactly what you think it is. It's a virtual private network. So here they're showing you how to install OpenVPN. It's actually the VPN that most places like Hack the Box and them use. So you may already be familiar with this, but what it is it allows you to have an encrypted channel between you and whatever device you're talking to, and so you don't have to worry about that communication. It's encrypted and it's hidden. So you can see here they're showing you how to install it. Here they're doing the configuration file. Super easy. Most everyone's probably used a VPN at some point and is familiar with it if you're watching this. So all right, so working with web services. So this is what we were talking about. I said, hey, okay, we want to install the Apache 2. But what does that look like? Well, once we actually install it, we have to start it, right? When we start it, now our web server is being hosted. So whatever is in that var www.html file, directory, usually there's an index.html. That's your home file. This is what it looks like by default. So Apache's default, and you can see there it is, var www.html, index.html. So you can change this HTML file to anything you want, and it will display as a website. Now, you can see here they have the configuration file where you can set the ports to whatever you want, listen on 8080, listen on blah, blah. This is really important to understand if you have a specific firewall requirements or something. Maybe you don't want to use these, whatever. You need to know how to change those. And then from there you can say, hey, curl, and then you can grab that. In this case, they're using localhost, right? And then they get the headers back saying, yeah, well, you connected, great. Now here you can say curl localhost. Again, you're going to get just the raw HTML. But if you type wget versus curl, you notice they get the actual download. So they downloaded index.html. So that's really a big difference there. Doesn't really matter how you do it, because you could do it vice versa. You could use curl and then download this. You could just have it with a little caret here that saves it as an index.html. Python 3, we talked about that. Whatever's in that directory is going to be served up on a website. Then when you go to localhost 8000, you notice they access readme.html and it displays it just like a website. So Python Simple Server is one of my favorites. It also has logging enabled really nice here. Again, Python's one of my favorites. Find a way to start an HTTP Simple Server inside the Pwn box or your local VM using npm. Submit the command that starts the web server on port 8080. Use the short argument to specify the number. You can see it's just http-server tac p that's why they said use the short argument instead of tac port, and then 8080. And then find a way to start a simple HTTP server inside Pwnbox or your local VM using PHP. You could just Google PHP simple server and you'll get this PHP tac s whatever 127.0.0.1 and then 8080, and there you go. Super easy. It's something that you all should do. At least play with it, understand it once or twice, because you're going to be transferring files back and forth your whole career in IT, and you want to know how to do it. Okay, backup and restore. So this is something I'm not going to cover in great detail because it's whatever you want to use. Like, there's so many ways to do this. They don't really talk too much about incremental versus full backups, but they kind of do. So they're talking about here, they're using rsync. Here they're just showing you how to install it, sudo apt install. Rsync, this is them backing up a local directory, and they're backing it up somewhere, right? But that's not the full, like, that's not your whole computer, that's just a local directory. So maybe there's one directory that you know has sensitive data and you really need it backed up. And then here you can see they're getting a little bit more complex. They're saying, okay, we want to back this up, right? And if you read all this, they're saying the backup option creates incremental backups. That means it's not going to completely back everything up every time. It's going to back up anything that's changed since the last time it backed up. And then the delete option removes files from the remote host that is no longer present in the source directory. So if you don't have files in the source directory anymore, they're going to get rid of it. Then here, this is how to restore. And then encrypted rsync. So this is what I'd recommend anytime you're doing, anytime you work with compliance, legal, really any company at all, you need to have your backups encrypted in transit and at rest, meaning even when you do the encryption and transfer them to a location, it should be encrypted the whole time. So this is what you should be doing. But you can see here, they're saying rsync and they're using SSH to create that secure tunnel. And you can see if you want to auto synchronize it,
they're using a key generation. If you guys know, SSH can use public and private keys. So what that means is I can have a private key stored where it's basically like if I have that private key, it will let me in. That's pretty much what it is. It's like a free pass in, basically. And so you can generate the key and then have that key sitting here so that it can basically do this autonomously and have it scheduled or something like that. And then you can see they're using a cron tab and they're setting that to backup.sh. Basically, they just scheduled it. So they scheduled it and they did it encrypted. So if you're ever looking for like, I really need to back up my data, I need to do it securely, I need to do it the right way, follow this exact step and you'll be right as rain doing it. And there's a million platforms out there, by the way, to take backups and encrypt them. So, all right, file system management. So most of us know on Windows how it kind of looks like a C drive, D drive, all that stuff. But here we want to talk about this. You have your ext2. It's an older file system with no journaling. ex3 and 4, they're more advanced with journaling, which helps in recovering with crashes, which is very important to most people. It's the default choice for most modern systems. Then you have your BTRFS, is known as advanced features like snapshotting, built-in data integrity, and stuff like that. That's really nice for complex storage systems. You don't necessarily need something like that for your just home computer. XFS excels at handling large files and has high performance. Again, probably don't need it for your personal computer, but maybe you do. Then you have your NTFS, originally developed for Windows. It's useful for compatibility when dealing with dual boot systems. Okay. Okay, so Linux file systems structure is based on Unix modes, which most people might know that. You guys might not know that. Unix's original Linux came from Unix, excuse me. The structure consists of several components. Indos are data structures that store metadata about each file. All right, so we have our regular files, which we all know what those are. That's every file we've looked at. Then you have your directories. Your directories are like folders that store the files. Then you have your symbolic links. So in addition to your regular files, Linux supports links, which act as shortcuts. So for instance, if I have a file that sits in like a deep directory, but I want it on my desktop on Linux, I can create a link, a shortcut. Same thing as on on Windows, excuse me. All right, so now we have our disks and drives. So here you can see if you want, the main tool for disk management on Linux is fdisk. So here they say fdisk tech L, and that lists the disks. Whatever disks you have, you can have them partitioned, whatever. You have to mount these. It's different than Windows, excuse me. Windows, you still have to mount them, but you can do it through GUI. You just go into the GUI interface and like right click and So if you put a new hard drive in your computer, you have to mount it typically. Sometimes it'll just auto detect. Linux does not really auto detect. At least I haven't seen it auto detect. You almost always have to mount it. So you can see here, my mounted file systems at boot. So the etc fstab, you have to go in here and say mount at boot, right? You have to tell it that. If you don't, you have to mount it every time. So when you hit mount, it's going to list all the mounted drives. So for instance, if I plug a USB in or an external hard drive or even an internal hard drive, whatever, I have to mount those. I've done this a handful of times for multiple reasons on Linux servers, but you can see here, you got sudo mount dev sdb1 and then mount USB, and then you can just cd right into mount USB, and it's just like it's on the machine itself. So that's pretty much all you have to do there. Then you have to use umount or unmount to unmount it, right? And then here they're saying, okay, we can use the lsof command to list the open files on the system. So the reason you might do this is if you're trying to unmount something and you have files that are open, it's just like your Windows computer, it's not going to work. And so you're going to have to go through and actually close those files or kill it and then risk data corruption if you try and just unplug it or something. So here's the fstab file. You can see it's asking us, okay, dev sda1, and that's a ext4, etc., etc. And then here, this is the externally mounted one, 192.168.1.100, and that is being mounted here. So very quickly, you can actually just add these, and if you have network drives everywhere, you can just mount them. Okay, so creating swap space. So this is deeper than you probably ever will have to get in Linux unless you're like a Linux engineer.
But swap space is an essential part of memory management in Linux. Basically, what you're talking about here is swapping memory, RAM. So you're swapping memory for different things. And the reason you're doing this is if you're using something that's very high memory usage and things like that, and you need to close something down, or maybe you have things in the background running that you need some of that memory, you can swap them. Again, I'm not going to dive deep into this. You don't necessarily need to know this. Just know if you are running into some RAM or memory issues, like memory intensive applications, blah, blah, and you need more space, this is an option. Make sure you really understand what you're doing, because memory is a big deal. So it says how many partitions exist in our pwn box. Well, up here we saw the command we can run right here, and it will tell us how many partitions we have, or it should. So let's see. Okay, it looks like 3. Let's see if that's right. There you go. Pretty easy. All right, so containerization, this is the last piece of it. Containerization, one thing that people kind of have a tough time with containerization is understanding what they are. Containers are basically, think of a virtual machine, but without the operating system. You don't need the full operating system. What I mean by that is we'll go down here and we'll look at Docker. This is the whole Docker file that will spin up a really nice Docker installation. So what you're looking at is you're saying, okay, update the system, install the certificates, all that stuff, right? You're giving it a set of instructions, and then you're saying right here, download the Docker. In this case, they're going to be using, it looks like Ubuntu. So they're going to be using Ubuntu to download a Docker image of Ubuntu, which just means it's going to run the shell of Ubuntu, meaning it doesn't need all the extra fluff. It's just very minimal resources, and it runs on top of your system, but it's contained, so it's secure. It can't come out. It's theoretically, right? And then you can see, but what you could do is you can do things like user mod, AG, Docker, Hackbox student, right? All this stuff. You can add instructions like adding users, installing services, all that stuff in here. So the point of it is, let's say you have a very specific use case, like the example I use is like when I run my end of year CTF, I use Docker containers so that every time a person needs to spin one up, you click the button, boom, Docker container spins up. It has all my instructions. If I need to tear it down, if I'm doing something where I just want to delete everything, I can turn the Docker off, spin it back up. It's just those set of instructions, and it just runs exactly what I want in a contained environment. The beauty of this is it's using very specific resources. It's not being like, think about Windows when you first install it. There's so much fluff in there. There's so much adware and all that crap. You have to go through and like delete and get rid of all of your stuff. This is like getting rid of, is like containerizing and saying only run the bare minimum I need to do these tasks. That's kind of the way to think of these containerizations. And you can see this is a better Docker file. They're saying, hey, grab the latest Ubuntu version, update it, install Apache and OpenSSH, remove the file here, then echo Docker user password, change password. So they're going to change the password for the user. And then they're going to say change the owners of these files, and then expose these 2 ports to the outside, and then start the services for SSH and Apache. So doing this would basically stand up a web server that has an SSH shell that you can go into. Keep in mind, if you take that Docker container down without saving or anything, and you next time you need to spin it up, let's say that website gets hacked, you could turn it off, spin it right back up in a matter of seconds, because it's just going to follow these exact instructions. It's going to get rid of anything that was new unless you have it saving. Okay, here's the syntax. You run the port, host port, Docker port. So for instance, if I want to run on my host port, port 80, and then on the Docker container, that's port 8080, then when you try to go to the website on my host, it'll be on port 80, but it's in the Docker container, it's port 8080. Docker management, Docker PS lists all the containers. Docker stop stops the container, a specific container. Docker start starts a container, restarts a container. Remove a container, RMI, remove a Docker image, and logs. That views the logs of a container, but doesn't view the logs inside the container.
the inside is basically, depending on what you do, in this case, in a Ubuntu server, it is just like an Ubuntu server, but it's just going to be command line where there's logs in there and everything else. Okay, Linux containers, these are all different containers that you can do. System level containerization, image building, so again, you can build your own images. Docker excels in portability. You can take those images. I can take a Docker image that has everything I want to run it. I can move it to your Linux machine. I can put it over here. I can put it over here. I can put it on anything that'll run Docker, and it will run exactly what I want. Containers are more secure because, again, they only run the necessities. So therefore, unless I add something, it's only running the bare minimum. Install LEX. Here's how you install it. Creating a container, here's how you create a container. Very simple, very much similar to Docker, the same commands. Securing it, here's your configuration. One thing you'll learn is in Linux, everything that you want to configure is a file. You don't need to get crazy. It's right here, right? Here's the memory limit, here's the CPU shares, etc. It's a file, you edit it, then you restart the service, and boom, right? So very, very easy, very, very simple. Containerization, they give you these 9 exercises to practice if you want, but I recommend if you haven't messed with Docker, just play with it. It's not hard. You can add very simple instructions. It's kind of like bash scripting, and you'll be able to start running away with it very quickly. So hopefully this helps you guys. Hopefully you guys have a great day, and when we get back, we'll do networking and hardening and the distributions tips and tricks. So hope you guys have a great day. Thanks, guys.
Yo, what's going on, guys? Welcome back. Today we are on the last part of the Linux fundamentals. We are going to finish network, looks like just Linux networking, hardening, then the distribution versus Solaris, and then tips and tricks. So there's no actual hands-on portion of this, so we're just going to walk through it. But basically, there's a couple of things. They mention as a penetration tester, one of the essential skills, blah, blah. This is useful for anything in IT, not just penetration testing, not just cybersecurity, not just anything. It's useful for anything. You should know how at least they have some sort of networking background and how it operates, because otherwise, you know all the systems, you have no idea how they communicate with each other. It makes it almost impossible to really dig in deep. So they talk about here, and keep in mind, I'm going to go through this quickly because most of this is just networking fundamentals, which there's an entire other sections for. This is not a networking course. This is just the Linux piece of it. So I'm not going to teach you networking in this. I'm just going to talk about the Linux piece. So network access control, NAC. This is one of the most common things that as a pen tester, you definitely need to know about, because this is what's going to prevent you. So there's these types: discretionary, mandatory, and role-based. We're going to talk about all of them. Then there is TCP wrappers, SE Linux, and AppArmor we're going to talk about as well. And then we're going to talk about logging. The reason I'm purposely skipping through some of this is it actually comes up in bigger sections, so we're going to talk about it. So the first thing is configuring network interfaces. So this is something, if you have dual homed is what they're called, network interfaces, meaning like you have a server or even your home network. If you, like my home computer has a wireless interface card and a like physical hardware one, right? Well, that means I can be on 2 networks at the same time, which I do quite a bit. I'm on my private home lab and I'll be on the internet. Now, the reason this is vital to understand is you have to know how to set this up from a Linux perspective. Otherwise, you can't do anything with it. The other reason is this is a prime target when you're pen testing. If you find a dual home computer, cha-ching, because that means you can access, if you have access to it, you gained access through one of the NICs, and now you're going to you can gain access to another network through the other NIC, right? So most of you are probably familiar, but you can use ifconfig. That's kind of the older way of doing it. I still do it that way. Nothing wrong with it. But a lot of times now it's going to IP address or IP ADDR. So either way, you can see all of your interfaces. You can see we have ETH0 is interface 1, ETH1 is interface 2, and low is your loopback. So loopback is always your own. So you can see this one is dual homed. They have ETH0 is on this network, 172.32.126. And this one is on the 10.106.0.66. That's not super uncommon. That really what that's showing is you probably have network address translation set up, DHCP, something like that. You have it set up somehow where you've connected to a network and you're probably connected to the internet, but then you have like a VPN where you're connected internally to another network. This doesn't necessarily mean that there is 2 physical network interface cards. It just means that there's 2 interface cards. So when you spin up a VM, you probably have 2, same thing. Okay, so now we keep going. You can see they're teaching you how to actually activate it. So if you have one that's turned off, if you have a VM where you're going to spin up multiple virtual network interface cards, you can go ahead and do it that way, like turn them on the machine, but then you have to turn them on the software or on the OS. And so you say sudo ifconfig in this case, or IP link, either one, and they're just saying eth0 up. So if you guys have ever done any wireless pen testing, you will know that it's pretty common you have to turn them in monitor mode to make them work. That means you can't connect, which means you almost have to have 2, unless you're just going to do it all offline, which is fine. But it's really important to understand that you can turn them up or off, or on, excuse me, and down for off. You need to know how to turn them on and off because, again, there's times where you need them on and off. So now assigning an IP. So again, I'm not going to talk to you guys about how to network and how to do subnetting and VLANs and all that stuff, but you will need to change IPs to have static IPs on servers and hosts and things. And so you're going to say sudo. Again, they're using sudo every time. It's just so that it's done as root. They're saying ifconfig, eth0 for the interface, and then the IP address they want. So now that is now the IP. Make sure, though, you don't just do this and move on. You have to assign the net mask. Again, if you don't know how to assign a net mask, if you don't know what a net mask is, go do the networking box. Don't do this one and expect to know how to do networking. It's 2 different disciplines. So sudo ifconfig, eth0, net mask, and then 255.255. That just means it's a class C network, which is fine. That tells it what the gateway is probably going to be, which is right here. You have to add the gateway. So you have to say route. This tells everything, all the traffic to route through this. This is the same command, by the way. It's really useful. This is the same command that you're going to use when you're using machines to pivot and things like that. You're going to use route. So you're going to say route, add, default gateway. That's the route you want to add. And you're adding it to 192.168.1.1, and you're adding that on eth0, which is the interface. For anyone that's lost right now, it's fine. Make sure you go back and do the networking, because what they've determined is this is a Class C network, meaning it's a -24 network, right? And because of that, the gateway will be the first IP in here, which is 1.1. That's how they determine that gateway. Okay, now one of the big things here that they talk about is when configuring network interface in Linux, it's often necessary to set the DNS servers. You have to set DNS servers, or else you're just going to rely on the etc host file, I guess, but that's going to be just local and you're going to have like nothing. So you want to make sure, one thing that people get confused on these boxes is the difference between like their virtual home machine or their home machine versus, like, we're talking enterprise here. We're talking large scale. You do not use public DNS at a large scale typically unless it's going external. So what that means is if I'm going to go to an internal website for my company, it can't go to Google's 8888 server and say, hey, what's the DNS record? It's not there. It's only internal in my company. So you have to make sure you set that. That's what they're talking about. So you can see here they're saying sudo vim. Vim is just a text editor. They're going to edit and add their servers. In this case, they did add Google, which is 8888. So make sure you have your DNS records up to date. That's what they're saying. Then they're saying go in here to etc network interfaces and add that interface information, because otherwise when it restarts, it will go back to default to what's in the configuration files. So this is how you change it on the machine. This is how you change it after startup and make it persistent. You see how that's useful? If you're doing a pen test, having a way to add persistence to networking is very useful, especially if you can use it to pivot to other networks. Then you can restart it. That's just once you actually set it all up, you probably want to restart it, make sure it actually works. Now, network access control. This is where we're going to talk about discretionary, mandatory, and role-based. It is very important that you have network access control. This controls who's allowed and what's allowed on your network. So most of you probably are at least seen some of my videos, know what Active Directory is and all that stuff, and that's great. And you know that you can actually edit permissions and groups and all that stuff. That's great. That sets permissions on what you can do on the software, the OS, those types of things. But what can you connect to on the network is controlled by discretionary access control, and or NAC, which is network access control. So discretionary, this is basically discretionary. It's, hey, I'm going to tell what can talk to who. I'm going to say boom, boom, boom. You can talk to this. You can talk to this. You can do. It's based on my discretion, right? That's discretionary. That's the easiest way to remember it. Mandatory is, hey, you're going to have to meet these level of requirements to access something. So the way to think of that is like this. It says Mac is often used in operating systems and applications that require high level of security, such as military and government systems. So an example would be, hey, you can't talk to my network at all unless you have the IP that I'm looking for, the MAC address I'm looking for, an EDR solution that I'm looking for, that all these things. You have to check these boxes. And if you do that, sorry about that, guys. So mandatory access control, like I said, it is mandating that certain requirements are met for you to access a resource, right? The difference between this, a lot of people get confused, like, well, what's the difference? Discretionary, you're telling them what they have to do as well. But the big thing is mandatory is like, here's your bare minimum. You have to have this to get in. Discretionary is like, well, maybe think about a bouncer, right? A bouncer might come in and say, you have to be 21 or older to get in. You're like, all right, cool. 21 or older, check. 21 or older, check, right? Discretionary could be, hey, we actually allow 18 and older, but I get to choose who comes in. So you say, okay, 18, you can come in, you can't, whatever, right? Think of a bouncer that way. So that's the difference between discretionary. It's discretionary based on my discretion. Role-based, this one's pretty self-explanatory, right? It's dependent on your role. If you have X role, you can access X resource. If you have different role, different resource. If you have both roles, you can access both resources, etc. It's based on roles. Really nice, or really self-explanatory. Monitoring. So one of the things when you're monitoring, there's all kinds of ways to monitor. There's all kinds of systems out there. The big thing here is interpreting network traffic to identify security threats, blah, 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 all that stuff. Make sure you're just monitoring, whether you have packet captures, whether you have snort, whether you have whatever, make sure you're monitoring. You want to make sure that you have really good monitoring systems for network. At least capture the information. Use things like Wireshark, PCAPs, things like that to figure it out. But you want to make sure you're doing it. Troubleshooting. When you're troubleshooting, I'm not going to lie to you. When I first started using computers and doing hacking and stuff, way back, probably 20 years ago, and I'm not exaggerating, maybe 25, I started with these. Ping, traceroute, right? Netstat and TCP dump and all them weren't there yet, I don't think. But ping and traceroute, those have been around forever. I used to do that all the time. It's still relevant. It's still really useful. The foundations never change, right? It has to go somewhere, and you have to be able to track it. So when you do ping, if you can't ping something, now there's caveats to this, but generally speaking, if you can't ping it, you can't talk to it. So why, if you ping it and you're not getting a response, there's probably some of your issue right there, right? So if you're pinging 8888 and you can't connect to it, and that's your DNS server, guess what? It's probably a DNS issue because I can't connect to the DNS server. And for the running joke in all of IT is it's always DNS, right? So when you trace route it, you can see there's going to be stars. That's just the ones that your ISP basically doesn't want you to see, but it's going to show you all the IPs it's hitting. So maybe when you're getting like really slow delays or something and you ping that server, you find that, oh, well, the delay is actually right here. Notice it's 7 milliseconds. So what is that? And it could be, hey, you're going from your ISP or from your house to your ISP office, from your ISP office to another state, and that's what's taking so long, and that's where your bottleneck is. Well, when that doesn't sound really useful to you from your home network, but if you are a large enterprise and you have a SLA with that company and you say, I need XYZ times, and they agree to that in a contract, you now have a case, right? So this comes in really useful from the not just defensive side, but from networking side, penetration testing, right? If I'm going through your network and I'm like, Jesus, I ran this command, it's taken 20 minutes and I'm not getting a response, I can start troubleshooting what's going on in there. Netstat shows all connections in and out, even the ones listening. So like these don't have an active connection, but it's listening. This is really useful for catching attackers, and it's useful for attackers to determine who's talking to who and how can we actually use that to our advantage. Now, most common, what's this one say? Knowing which ports are used, which services. Yeah, so again, if I'm on your machine, I might do something like netstat and find, oh, ports that I didn't catch using things like nmap, now I see, I might be able to use that to my advantage because there might be something running locally on the machine that I can actually take over or whatever. Hardening. We're going to talk about hardening, so there's not really much. Oh, wait, this is the hardening section. So hardening. Couple of things. One, with Linux, if you're not a full-time Linux admin and you're not a expert, I'm not saying don't try, but don't do it professionally. Like, don't go to a company that has like 1 or 2 IT people and they're like, you're now going to harden all of our Linux servers, because you will get hacked. I'm just telling you. Linux is, you need to know what you're doing if you're going to harden it. It is much more secure if you know how to harden it. There are things like SE Linux, which is security enhanced Linux. There's Red Hat Linux, which is a paid. These all are things that basically sit on top of Linux or are Linux distros in Red Hat's case, and they already kind of harden it for you. So work on that stuff. You can see SE Linux operates at a low level, and though it offers strong security, it can be complex to configure. That's my point. If you don't know what you're doing, please don't do it. Just know, maybe I need to hire a professional to do this. That's fine. App Armor. So it's like SE Linux. App Armor is a Mac system, which most of you are probably familiar. If you use Mac, you're probably familiar with this. It operates simpler, more user-friendly manner. App Armor is implemented at a Linux security model and uses application profiles to define what resources applications can access. So tells them what they can access, right? And the reason I'm reading that one is I'm not very familiar with App Armor because I don't like Mac. TCP wrappers, we're going to talk about those shortly, but basically these are wrappers that say you can do this from this IP, or this person can talk to this person, that type of thing. This comes in really useful, especially when attacking. Because the more you look like a real person inside the network, the easier the attack becomes. And I can tell you, if I can look at your TCP wrappers, then guess what? I can now say, well, you allow this IP over here to talk to this IP using SSH. All I got to do is make it look like I'm this IP, and you'll let me in, and you won't notice because you'll think that's normal. Okay, now setting it up. Here's some steps if you want to set it up. Install SE Linux, blah, blah, blah. Configure SE Linux to prevent a user from accessing. These are just basic steps. Once you're more familiar with Linux, definitely start looking at hardening, but don't just go into it thinking just because you know Linux, you're going to start being an expert. It gets really complex. All right, so remote desktop protocols in Linux. This is something a lot of people on my Try Hack Me videos, I think, have said, like, how did you know to RDP? Like, this is just how it's just common in most environments that you RDP. So remote desktop protocol is primarily used in Windows environments, but it can be used in Linux as well, and we're going to talk about that. And then you have VNC. So VNC is virtual network computing. Anyone that's used, or VNC's been around for a very long time. If you guys have ever heard me tell the story about me getting suspended in high school for hacking, long time ago, this is why I was using VNC actually. And so just funny callback, I guess. So the X server, it's a user side part of the X Windows system network protocol X11. Doesn't matter if you know this, but that's why I've used X-free RDP. See the X server, that's what it's using, right? When a desktop is started on a Linux computer, the communication of the graphical user interface with the operating system happens via the X server. So you're interjecting yourself and saying, hey, when you do that graphical piece, let me see it. This is different than most Windows RDPs, because what you'll see down here is I can actually say, hey, I want to SSH, right? And then use TAC X, log in, and I want to run Firefox. Well, look, I actually pulled up just the Firefox window, and I did it over SSH. So this is actually using the SSH protocol to call on the X server, which runs the graphical interface of Linux and allows you to do this. This is really, 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 really nice because you can do things like this. The other nice thing about this is, guess what? You know what has a really nice VNC module is Metasploit. If you guys have never used it, I recommend it. It's one of my favorites. You can change the payload to say, hey, the payload, instead of being a interpreter shell, be a VNC shell, and let me just have full access to the machine remotely. That's really nice, right? X11 security. So X11 by default is not a secure protocol. So once again, we get back to, if you don't know what you're doing, please don't secure it, because you probably are going to miss something. So it tells you all the vulnerabilities and things like that. So be cautious with it. X Display Manager protocol is used by X Display Manager, obviously, for displaying communications through UDP port 177 between X terminals and computers. So again, using something slightly different, a different port and different usage, but same concept. All right, VNC, virtual network computing, remote desktop file sharing. Don't really care that you know exactly how everything works, but you need to know the port, because if you find that port, 5900, you know what it is. The other thing is, real VNC is the one that I actually got caught on, but you can see there's all kinds of VNC applications that you can use, etc. The most used tools for connections are Ultra VNC and Real VNC because of their encryption and higher quality. These are common. This is one thing that people don't understand is people always say like, well, this won't work because like, why would this be on a machine? But help desk, IT admins, all kinds of people use RDP and VNC for legitimate purposes. What that means is once we're in, if we know what they're doing, we can use it for our purposes and it looks legitimate. So understand and make sure you comprehend what's going on here with the VNC. It's just a way to remotely control a computer, but it's different underlying technologies. So you can read through and see and understand them better if you want. This is how to actually install it. Really easy to install. I mean, you can see it's 2 lines in this case. Super easy. This is VNC specifically. There's also VNC agents you can put on your Windows computer if you want to remote control your computer from that. All kinds of stuff. SSH tunneling. This is one of the things I was talking about earlier that you can do. Very, very useful here, right? So to encrypt the connection and make it more secure, we can create an SSH tunnel in which it's using SSH, which is secure shell, to do this whole process. And you can see that's what they do here. They say, hey, listen on 5901 on the local host, and then 5901, okay. And they're saying, send it to this. Basically what they're saying is route the traffic through this and through an SSH tunnel and do it. That it's the same type of thing that attackers do all the time for all kinds of different things. So just be familiar with it. Understand SSH tunneling is just a way. It's an attack vector, but it's also a way to just make something more or make something secure that isn't by default secure. So we talked about before. Hey, the X servers aren't typically secure. The X11, well, that's fine. Run it through SSH tunneling, and now it is an encrypted channel, and you can still use the application you want. You can see this is what it looks like. Tiger VNC. Now look at that. It opened up an actual thing, and they're in, right? It says ID. They're in. So there you go. And this is using tight VNC, you can see. So it's just a remote desktop protocol. Most of you probably familiar with some sort of remote desktop. Okay. Now we're looking at Linux security. There's not a whole lot on here actually, which is probably smart on their part, but this is one thing I don't see people doing very often, and even I'm guilty of not doing this. Linux is not always the same as Windows. It's not going to pop up and say, hey, there's new patches, right? Apt update and app distribution upgrade. This will keep your stuff up to date. You need to do this regularly. One thing to note, you can also just do this on a schedule, but one thing to note is especially people that use like Kali Linux and things like that, this can break a lot of stuff. So just know if you have a bunch of stuff working together, there's a chance it breaks it. That's why companies do patch processes with like testing and development and QA and all that stuff. Okay, then we talked about SE Linux and App Armor. Another common protection mechanism that can be used is fail to ban. This tool counts the number of failed login attempts, and if a user reaches the number, the host that tries to connect will be handled as configured. So basically I can say, hey, if you try to connect too many times, I'm just going to block you or whatever I want to do. Besides that, there are different applications and services. Snort, we talked about that. These are all kinds of things that can do whatever. Again, I'm not here to teach you how to secure Linux in a matter of 25 minutes. That's just unrealistic. It takes a lot of understanding how Linux works on the underlying systems, looking at things like Snort, going to those boxes, looking at these different tools, understanding those tools, applying them in the process in the places that you need. But some of the basic things you should be doing, we talked about earlier is the permissions. Disable SUID binaries. It's one of the most common ways to escalate privileges. Make sure you lock user accounts after login failures. This is done in Active Directory normally, right? We don't normally do this in Linux unless you go in and do that. So make sure you look at that. Make sure you have password aging restriction, passwords that actually retire, right? AD does this. Windows environments do this, but you have to do this in Linux manually. Enforce strong passwords. Ensure that each user has its own account. Don't use shared accounts. That's best practice everywhere. Ensure NTP is enabled in syslog. We're going to talk about syslog and why that's important. Removing all services that rely on unencrypted authentication. We talked about that. If you have to use it, try and use SSH tunneling so you don't have to use it unencrypted, right? And then removing or disabling all unnecessary services and software. The nice thing about Linux is it typically already has this done, so you don't have to stress too much about it. When I say it has it done, I mean typically when you stand up a brand new system on Linux, like just a server, it doesn't have anything on it so you have to put those applications on there. So if it's there, you probably want it. All right, TCP wrappers. You have your hosts allow and host deny. You can see hosts allow, they have SSHD, allow from this entire subnet, this class C network here, 10.129.14.0 through 10.129.14.255, allow all of them to SSH. This locks down the SSH protocol so that you have to be internal in the network to do that. Same thing with FTP, Telnet, all that stuff. Now the deny access to all services from hosts in inlinefreight.com. So deny it explicitly, right? If you have threat intelligence that says someone's going to be attacking from this domain, you can deny all of it, right? Things like that. Very good information. Firewall setup. We're going to go through this briefly. A lot of people use the UFW rather than the native firewall like this. You can use whatever you want, but you have your IP tables. This is where you're going to actually have organize your firewall rules. It's just a way to put all your firewall rules in there. You're going to have your chains. Chains are used to group a set of firewall rules together. And then your rules, these are the actual rules themselves. Matches are used to match specific criteria. So if you have like a broad criteria, but you don't have a specific rule, you can do matches. And then targets specify the action for packets that match a specific rule. So if this matches this rule, do this, right? All right, so here we go to tables. When working with firewalls, it's important to understand how tables work. Tables and IP tables are used to categorize and organize firewall rules. So these tables are used to organizing. Each table is responsible for performing, a specific set of tasks. So you have your filter, used to filter network traffic based on IPs, ports, and protocols. This is what you're probably most familiar with. Then you have your NAT, used to modify the source or destination. This is typically if you have like network address translation where, hey, I'm going to be, all the internal network's going to come out from one IP, right? You have to say that so that the source and destination gets modified. That's something that you have to understand. And then mangle, used to modify the header of the fields if there's a reason you want to modify it. Maybe you don't want to give away any data. Maybe you're standing behind a firewall for some security reasons, et cetera, et cetera. Okay. Chains, you have your built-in chains. These are your pre-builts, basically. Then you have your user-defined chains. The built-in chains are predefined and automatically created. Yep, which makes sense. You have your input, your output, and your forward. Then you have your pre-routing, post-routing. These are things that are going to happen before the routing, after the routing. Really simple. The pre-routing chain is used to modify the destination IP. So again, if there's a reason you need to change the IPs, that's what it's for. The post-routing chain is used to modify the source IP address of outgoing packets. Yep. The mangle has 5 built-in chains. Pre-routing, post-routing. We talked about output, input, and forwarding. Okay. User-defined chains can simplify rule management by grouping firewall rules based on specific criteria. So what this means is if I have like security firewall rules, right? I can have them all on a chain and it can simplify the way we manage them because when I make a change, it does it to all of them. It's a nice way to say, hey, maybe all of these rules are going to get blocked versus, hey, all of these, I have to put a block action individually on each one. So, all right. Now, here is the rules and targets, meaning rules and what you can do with them, right? You can accept them. So I could say, hey, allow it to come through. If I have like a specific person I do business with, something like that, I could be like, your IP on this port, we do business all the time. You are allowed at all times. You can drop it. If you know, hey, I don't want anyone talking to me on port 22, drop that packet, right? Reject it, drops the packet and sends an error message. Now, this is effectively the real reason for this would be like for error logging or something, but you're basically telling the person, hey, you're not allowed to come in this way. That's fine. Then you can log it. You can say, hey, whatever happens here, I want to make sure I log this port or this IP because it's sensitive data, whatever. Then modifies the source IP. This is what we talked about with network translation. You have your source, your destination, your masquerade, similar to it, but used when the source IP is not fixed. So dynamic IPs. Redirects the packets to another port or IP. This happens actually very commonly with like a lot of websites redirect you to something else and you may not even notice. If let's say you have what do you call it, like load balancing or something like that on your websites, and you have like 10 servers that are actually hosting the websites, and you have a firewall rule that says, hey, redirect this at some point. Usually that's all done already, but I'm just saying you could do it that way. Adds or modifies the net filter mark value, which can be used for advanced routing. Okay, so now we're looking at the actual commands. So here you can see sudo. They're using IP tables. They're doing the TAC A adding. They're adding an input. The input is the TCP port. So anything on TCP, the D port is destination port. So anything on TCP port 22, accept it, right? So really easily, you can tell right away, hey, if someone's trying to connect to me with TCP on port 22, I'm going to accept it. They don't have a specific IP here or anything, so just everybody. Now, matches, P for protocol, that's what they've got here. The protocol itself is TCP. I think I said port, but I was reading this. So you can see, then you have D port, which is destination port. You have S port, which is source port, blah, blah. Just a little cheat sheet for it. And then you can see this one, same thing, but this one, they're adding the input. They're adding the protocol is TCP again. They're saying match, if anything matches TCP, right? And then destination port 80, accept, right? And so it says here, the rule matches incoming traffic, TCP on port 80, if it matches that, right? And jumps to the accept target. So it's jumping, if the match is successful, it jumps to it, right? All right. And they're just showing you two different ways to do that. The firewalls, if you guys don't understand networking, you're going to need to go do the networking box. Now, here is where it's very important to understand not only logging, but if you're on an attacker side, the understand where you're going to generate logs as well. I'll say that. So you have your kernel logs, right? These are the log information about the system's kernel, hardware drivers, when something crashes, overheats, that type of thing. Here's where you're at, right? This is where you're, they should be, var log kern.log. Again, every OS flavor may be slightly different, so you may have to dig around a little bit. Then you have your system logs. These are, if you've ever looked at your Windows logs, this is kind of similar. These are your system logs. You're going to have var log syslog. You almost always ingest your syslog to things like your SIM and stuff like that, because it's where most of your data is going to come from. It's not always true, but just know that it's common, right? You can see this what the syslog looks like. Command is user local bin backup.sh, failed password for the user, exception, okay, accepted password for the user, right? Get index.html, so that's a HTTP request with the user agent. All right. Start clean PFP session files. Okay, so that's basically what a syslog looks like. You can see it's kind of all the real important information. Now, authentication logs, you can see here they did say failed password for the Hack the Box student on port 50223, but there's also authentication logs, which you can see here as you go down. You got accepted public key for admin, so they have the actual public key, that's fine. And then you can see sudo, they have admin, present working directory, user, all that stuff. And then they end up getting disconnected, new session for admin, blah, blah. So this is the actual auth logs for the SSH. So you can see you're going to have to look for kind of in different locations. They're giving you all these locations. It's just knowing what logs are here and knowing what you're going to generate. Because, for instance, if you go in, depending on how they have logging set up, if you go in and you start spraying passwords, right? Like a lot of these CTFs and stuff people do, it's going to say, hey, try Hydra and try every password and username combination, right? Well, you're generating those logs. So what that means is it's very easy to tell that you're trying to attack the network because you're generating so many logs. So if you understand where those logs are generated, then when you're a really good pen tester, understand what data sources are being ingested, then you can change your attack method based on what they're ingesting. If you know what that is, you're really starting to get where you can get dangerous. Okay, application logs. These are dependent upon the application. Usually they're going to be in var log, whatever, Apache 2, MySQL, all that stuff. And then you can see access log. This is a specific access log, server name, privilege.sh, hack the box student accessed the root hidden API keys. That would be something if that's a specific file that you're like, hey, this is dangerous. We need to watch this. You'd put monitoring around that, right? Now, here's the location for the different logs. Really useful little cheat sheet here. I recommend checking it out. The security logs, depending on where you're at. This one they say, for example, the failed to ban application records, failed or log in there, blah, blah. But you have your firewall logs, you have your sys log, you have your auth log. Pretty much go to var log and start looking if you're wondering where to actually start finding your logs. Now, Solaris versus Linux. I have absolutely no understanding why they just threw this in here. Maybe they have a lot of people working with Oracle. I don't know. I used to be a Solaris admin way back when. I haven't even touched it in years. You probably have heard me talk about using like ZFS and stuff in some of my videos. That's from way back when. I haven't touched it in I don't know how long. But you can see they're talking about Linux distributions versus Solaris. Solaris and Linux distributions are two types of operating systems that differ significantly. Solaris is proprietary operating system owned and developed by Oracle. It's true, meaning it's not open source like Linux. You can see Solaris is a Unix-based operating system versus Linux is Unix-based as well, but you get the difference. One's Linux, one's Unix. You can see this is kind of, I'm not really sure why, but they're showing you this is what it looks like. Then you can see Solaris has a number of unique features that set it apart. One of its key strengths is support for high-end hardware and software systems. Okay, it is designed to work with large-scale data centers. This is true. If you're working in data centers or any large place where you're doing this type of work, you're gonna see these. Solaris uses image packaging systems. Okay, they use role-based access. Differences. Here we go. The file system's different. The process management, package management, kernel and hardware, system monitoring, and security is different. Congrats, you now know it's all different. It's very different. Still underlying commands work the same, things like that. Just know that they are different. Here on Ubuntu, we use the uname command. And then you can see here on the other end, Solaris show rev tac a gives you that same thing. You might say, well, why do I need to know Solaris? You probably don't. So don't waste your time learning this. If you need it, there's cheat sheets out there. There's all kinds of documentation out there for their commands, that type of stuff. You can see they're just showing you the basics. If you need to add a package add versus sudo apt get, package or permission management, change mod versus, okay, where are we at here? There we go. Share, and then tac f, nfs, tac o, blah, blah. Okay, slightly different. That's fine. Mount versus here they use share. Okay, nothing crazy. Process mapping. You can see you use sudo for Apache to map the process. Here they're using p files. In Solaris, the p files command can be used to list all the files opened by a process. Same thing. It's just something different to learn, but it's just a Unix-based operating system. I'm not sure I'm not sure why they threw Solaris in here. I'm really not. Like I'm gonna be honest with you guys. They might have some information I don't. Maybe they are seeing a huge group of people using Solaris that were asking. I don't know. It just seems very odd to just randomly throw one module in here that says Solaris versus Linux, but whatever. Especially since Linux has 500 distributions, it feels like you could have walked through the differences in those versus this random one, but whatever. Okay, so you can see they use strace here to trace the system calls. Here they're using truss to trace them. All right, cool. Nothing really of value there. All right, now shortcuts. These are things that I'm not going to walk you through every shortcut, but these are things that I definitely would keep. I used to do this, and I haven't done it in years, but I used to keep a cheat sheet hanging on my desk. I would have like a pin board behind my desk, and I would have cheat sheets, and one of the cheat sheets I had was shortcuts for like Vim, shortcuts for this, for like just Linux commands, stuff like that. If you've ever seen anybody get really good at shortcuts and go into Linux, like a Linux admin, go in and you watch them, it's pretty impressive to watch. I mean, they can do some stuff really fast. It almost looks like the people that are doing like, I don't know what you call it, but where you're typing in like a court system, and I can't remember what it's called now, but, and like, if you look, they're not actually, the keyboard's like 8 characters or whatever, but they're writing just flying. I know it's transcription, but I don't know what it actually is called. It's kind of like that. So it's really cool. Check it out. Let me know what you guys think. Hopefully this helps you guys, and hopefully you guys have a great day. Thanks.